Yeah, hi everyone, welcome to PrepFusion. So in this video, we are going to see the solutions of the All India mock test that was conducted, which is IGNITEX. Okay. So as of now, when I'm recording this video, the test is not conducted yet. Test will be conducted, then this video will go out. But I'm recording the video before and only. As of now, the test is not conducted, but I have set up the question paper, no? So I know the question paper was on the tougher end. And this is what happens at the PrepFusion. If you are new here, then you might not be knowing, but this kind of paper we always set up. Okay, watch the video solution completely. It is going to be a video of more than 3 hours, so have patience, sit back and watch the video completely. You will learn a lot of new things, a lot of new things. The test is also still live. Okay, test is live only. You can still attempt the question paper. It will be available for till today. It will be available. Okay, so you can still attempt the question paper. It is live. If you haven't attempted it, then you can attempt it. Question paper was on a tougher end, no doubt about it. Is that understandable to you? So don't worry, everyone would have felt it on the tougher end only. As of now, I don't have any data. So what we will do is that we will talk at 6 p.m. The session would have been scheduled at 6 p.m. So we will talk at 6 p.m. today. Okay, and I will tell you about everything, like what was the paper level that we already know. There will be a lot of we will be coming live. Okay, this will be live only. We will be coming live. So there will be a lot of aspirant who has written this question paper. So they will be commenting down about the paper level and all. You will see the toppers marks as well, that how much marks toppers are getting. Average marks also I will tell, and what should be a good score based on the marks that people have got. That I will tell you. Okay, so don't worry. Even if you are getting 1 mark, 2 marks, 3 marks, 4 marks, 5 marks, even if these low marks are there, no, still you don't need to worry, because we are having 200 days left. 200 days in the best possible way we will utilize, in the best possible way we will learn the things, and we will surely perform well in the examination. This was just a wake up call. Although we usually we conduct the concept X test. Okay, which test I will talk about it. We conduct this concept X in September, but this time I thought that let's bring one in July as well. Okay, because in September as well some people feel like that, sir, it is too late. So what I thought was, let's bring one in July. Even if you have attempted, even if you have studied one subject or two subject, let's bring this test so that you get a temperament of how you need to proceed in 200 days. Now you are having 200 days. In the best possible way you can prepare. Okay, so no need to be demotivated. No need to be demotivated. I will come live with the data. You will see that everyone is performing poor. You might have seen that, sir, I got 20 marks, sir, still my rank is rank 20 or 25. This much rank I am getting. So it might be possible that some people would have used AI, right? So we have the tools. If someone has used AI, no, so I will be able to know that if this guy has used AI or not. So I will be deleting his response. So don't worry about anything that, sir, this was my rank, this is my marks. I know everyone would have performed poorly only. Although the test is not conducted yet, but still I know that getting 25 plus marks is very difficult in this question paper. I am already telling you. Like if someone is getting 20 marks, no, then he is very good in this question paper. If he is getting 20 marks. 20 marks are very good actually. Because getting 25 plus is very difficult in this question paper, that I am telling you. Okay. Now let me tell you something, like if you are feeling demotivated, so something let me tell you. So this is the mock test that we conduct in September. This was conducted in September 2025 gate 2026 aspirant. So this guy was an aspirant back then. Okay. So he wrote down this particular test. It was of 100 marks. He got 62.68 marks, which are pretty good actually. The level of concept X and the level of IGNITEX. So I will say that IGNITEX question paper is on a tougher level than concept X. Okay, concept X was also tough, but IGNITEX is a bit on tougher level than concept X. Secondly, here there were two more subjects, control plus signals. Okay, there were two more subjects, control plus signals. Here there were 5 subjects that you already know. Here control plus signal was also available. Also it was conducted in September 2025. It was of 100 marks. This paper was of 50 marks. So what is the scenario? This guy got 62.68 marks. What was his actual rank in GATE examination? 22 rank. He got 22 rank in GATE. This guy Shubham, he got 50 marks here. What was his actual rank in the GATE examination? It was 32 or 33, I don't remember. Roughly around 32 rank. Kashi, he got 50 marks in this question paper. What was his rank? His rank was roughly around 60. Roughly around 60 rank he got. Mohak, he got 46.68 marks in this question paper. What was his actual rank in GATE examination? 9. He got 9 rank in GATE examination. and all of them are honest. Okay, in gate 126 there was cheating scenario and all. I know them personally. I have seen their responses. As of now, you feel like that, sir, only 63 marks, sir, only 46.68 marks. It is very difficult to score here. Okay, so I would say it is nearly same only because here two more subjects are also there, no, right? So and in concept X we actually set up aptitude in a tougher manner, but here we are not setting up aptitude in a tougher manner. IGNITEX aptitude was on a easier level only. So I would say paper level was nearly the same. So you can see their performance. Shumeda 37 marks something. Her rank was roughly around 100. Roughly around 100. He got Chandrasekhar. He got 31 something marks. His rank was also roughly around 100 only. Roughly around 100 rank. Okay, roughly around 100 rank. Sharvari, she got 25.34 marks. Her rank was 80 rank. 80 rank in final gate examination. So I'm just telling you that lower marks doesn't mean that you are not going to perform well in the gate examination. They gave a fair attempt. I remember the effort of Sharvari after this test. Okay, she was a regular student. She always used to tell about her progress and everything. She put up the level best after September 2025. I remember her. So that kind of effort she has put, and she got 80 rank. Same with Ayush, Shubham. They were like always connected to me. You can see their ranks. No matter whatever the marks they are getting, although they are very good marks only. Okay, not to say anything wrong, like they are very good marks. These marks are also good only. So I'm just telling that whatever the marks as of now you are having, don't be demotivated with that. You just need to study well. That's the bottom line. Again, detailed analysis we are going to do at 6 p.m. I will show these data as well. Along with that, I will show the data of current test as well. I don't know how many people will be writing this test because the scenario is that as of now people are not that confident, right? So not a lot of people will be writing this test that I know, but at least I would be expecting that 300 people will be writing this particular test. 300 aspirants I will be expecting. Okay, so let's see how many people would write. As of now 300 I would be expecting. So don't be demotivated with anything. This is what I'm telling you. Okay, yeah, you can study from anywhere, from wherever you are studying. You can study from there. If you want to study from PrepFusion, then these are the courses that we have. Along with that, we are providing a discount code PREP. Okay, so I will keep this code till tonight. Till tonight I will keep this code. You can get till tonight, or let's keep it till tomorrow night. Till tomorrow night I will keep this code till tomorrow night. Okay, till tomorrow night I will keep it. So you can get the Pathfinder swatch in 5,879 rupees and Titan swatch in 9,529 rupees. Okay, what are the features and everything? So you can watch the launch video. You can simply go to YouTube and type GATE 127 EC full batch orientation PrepFusion. GATE 127 EC full batch orientation PrepFusion. GATE 127 electrical full batch orientation PrepFusion. You will get the video. You can see which subject is being taught in how much hours, what are the features of the course. You will be getting video lectures, one-to-one doubt solving will be there, personalized doubt solving will be there, mentorship will also be there from your own educator, like from me and Anish sir. Along with that, slides would be there, printable notes would be there, all these things would be there. So all the features and everything in detail you can watch from here if you are thinking to learn from PrepFusion. And the quality of the question that we have framed, in the same quality we teach as well. And please do watch the solution of every question. You will get to learn a lot of new things. Okay, yeah. Thank you very much, and let's meet at 6 p.m. I hope you guys will be joining live. Let's meet at 6 p.m. for the review of this question paper. That what is the performance of the people around you. Okay, yeah. Thank you very much.
So here we have three capacitors C1, C2, C3, C1, C2, C3, and their capacitance are also shown, and their initial charges are also shown, that before closing the switches, because both S1 and S2 are closed at equal to 0, before closing it, the initial charges were as follows. Determine the final charge of capacitor C2 expressed in coulombs C after the circuit reaches steady state. Basically, they are asking me the final amount of charge in capacitor C2. How will I calculate it? So, of course, I have solved many circuits like this in my lecture series that was taught in PrepFusion Hindi. If you want to learn more about switched capacitors, you can go and watch this particular video. This is in Hindi language. Like we have taught a lot of concept. If you don't know any concept regarding switched capacitors, you can go and watch this particular video. Now, here, what needs to be done, I will first of all explain you the shortcut version. How can you solve it really fast? And then I will break down into smaller components. If you want to understand even deeper, I will explain that. First, I will solve really fast. So if I notice one thing, that this circuit is a closed circuit, right? this circuit is a closed circuit after t equal to 0, because if I close the switches, what will happen is I will have a capacitor. I will have a capacitor here. The switch will be closed. I will have another capacitor here. There will be a resistor, and I will have another capacitor here, right? So whatever charge, let's say this capacitor is discharging, so it has to flow into either this one or this one, right? Or let's say this one is discharging, right? So it has to flow to either this capacitor or this one. We have no other path, no other option. So here we can apply simple charge conservation. Simple charge conservation. At steady state, what happens? At steady state, the currents across the capacitor is 0. Why? Because C dVc by dt is 0, because there is no change in voltage. So if I draw the circuit at steady state at t equals to infinity, as the current will be 0, so I can assume the resistor to be not present. Why? Why so? Because the current is 0, right? Current is 0 amperes. If the current is 0 ampere, the drop across the resistor would be simply 0. 0 into R is 0 only. So we don't have to worry about the resistor anymore. So all these three capacitors are in series. So what is the final charge? We can apply charge conservation. Q initial equals to Q final, because this is a closed circuit, and if some charge is leaving out from one of the capacitor, it has to go into either of the two capacitors, right? So that's why initial charge will be equals to final charge. Right now, just give me 1 second. Yeah, what is the initial charge and what is the final charge? Initial charge we already know, 0, 2 and 1 coulomb. This is the initial charge, right? This is the initial charge. One more thing I forgot to mention, this, that I should have mentioned the this polarities as well. My bad. Should have mentioned the polarities as well, right? This will be mentioned in the question. Okay, my bad, because like this same polarity will be taken for the voltage as well, right? So let me write this as v1 of 0 minus, or let me keep it as q1 only, that's fine. So I should have mentioned the polarity. So obviously all of them are at same polarity. What is the initial charge? I will add all of them because all of them are in the same direction. If you don't understand what I'm talking about, please go and watch this video, right? So I will add all of them. So 0 plus 2 plus 1, that is 3 coulomb. So initial charge is simply 3 coulomb. What about the final charge? So obviously if I assume a voltage like this, V final, right, or Vc of infinity, so what will be the charge stored by each of the capacitors? So this one will be Vc of infinity into C1, because Q is equals to Cv. So C1 into Vc of infinity plus C2 into Vc of infinity for the capacitor C2 plus C3 into Vc of infinity, right? So overall my Vc of infinity comes out to be 3 divided by C1 plus C2 plus C3. So 1 plus 2 plus 3, that is 6. So Vc of infinity comes out to be half volts. But what have they asked? They asked me the final charge in C2, final charge stored in C2. So that would be equals to simply, I know Vc of infinity, right? So what is the charge stored in C2? It is this value only, right? Q2 of infinity, right? So Q2 of infinity would be equals to C2 into Vc of infinity. C2 is simply 2, Vc of infinity is simply half. So this will be equals to 1 coulomb, right? So your final charge stored in the capacitor C2 would be equals to 1 coulomb. This will be your answer of the question. Now, you might have some doubts. Sir, how is it? I have seen in some circuits, sir, the charge is not conserved. If you notice, if let's say this capacitor in the middle was not there, this capacitor in the middle, so if you see that the final voltage is not 0, even though this is a source free network, the final voltage is not 0. Sometimes you have seen, I say that source free network, final voltage will be 0. How? So the capacitor needs a parallel path to discharge. In this case, there is no path for the capacitor to discharge. But what if I change the circuit or modify the circuit, that if this capacitor in the middle is not there, then this will be a source free network and both the capacitors can discharge through this resistor. If one is discharging, it is not flowing into the other capacitor, right? It is discharging through the resistor. So we have a parallel path for discharge. So that is the difference between this circuit and this circuit. In this circuit, I have all capacitors. If one capacitor is discharging, other capacitor has to charge. There is no parallel path. But here I have a parallel path. So in this scenario, the final voltage will be 0. But in this scenario, the final voltage will not be 0. Now, what is happening actually in the circuit? Actually in the circuit, as the moment I close switch S1 and S2, right, just before it, this had some voltage, this had some voltage, right? So the voltage in C1 is simply 0 because initial charge is 0. So voltage across C1 is simply 0 volt, right, just before closing the switch. And this C2 has a charge of 2 and its capacitance is 2. So Q equals to CV. So the voltage would be Q by C, that is 1 volt. Voltage across would be 1 volt in this direction, right, according to the polarity given. And I have a resistance of 1 kilo ohm, that is fine. And then this switch is also closed, and this capacitor, I'm just drawing it just for t less than 0. This capacitor has charge of 1 and its voltage is 3. Sorry, and its capacitance is 3. So its voltage would be plus minus 1 by 3 volts, like this, just before t less than 0. Right now, just at t equal to 0, what will happen? You will close the switch. Now there is a bit of KVL violation. Where is the KVL violation? The KVL violation is only with this particular capacitor and with this particular capacitor, not with the middle one. Why so? Because if we apply KVL here, we have a resistor, and if I have a resistor, what will happen? If I apply the KVL, the voltage drop across the resistor would simply come out to be 1 volts, right? If you apply the KVL according to this, or according to this, it will be something finite. And if the voltage is finite, then its current across the resistor also will be something finite. Either if you go by the right hand side or the left hand side, any equation, both will yield to the different voltages. That is another discussion, but the voltage will be finite. If the voltage is finite, the current through this resistor is finite. If voltage is finite, current is finite. And if this current is finite, that means the current through the capacitor is finite. And whenever the current through the capacitor is finite, the voltage will not change suddenly, right? Voltage will remain at 1 volt only. So this capacitor will not change its voltage instantaneously. But obviously, KVL is violating in the outer loop. So we know the concept of switch capacitor. We can apply the charge conservation. Some finite current will flow, but through these two capacitors, we can apply the charge conservation. So if I apply the charge conservation, initial charge across this capacitor is simply 0 because voltage is 0, plus this capacitor had initial charge of how much? 1 coulomb. Simply C into V equals to, now just I'm talking about, this is just at t equal to 0 plus, right, and this is just at t equal to 0 minus. So at t equal to 0 plus, what is the charge between these two capacitors? So again, these two are in directly parallel with each other, so the voltage will be same, and the capacitance of C1 is simply 1 farad. This is 1 plus this is 3. C3 is 3. So your V comes out to be 1 by 4. So the voltage at t equal to 0 plus comes out to be 1 by 4. I could have asked that question as well. What is the voltage at t equal to 0 plus? So t equal to 0 plus, the actual voltage that comes out to be is 1 by 4 at this node. So if the voltage here is 1 by 4 and this has 1 volt, so you can calculate the voltage here, which will again yield you some finite current. But still some current will flow, right? Will not reach steady state. And due to flow of current, what will happen? The voltages across the capacitors will change, but we have come to the conclusion that yes, whatever current flows, it has to flow somewhere in the capacitor, due to which the charges will be conserved. You can again apply the charge conservation at this point as well. From t equal to 0 plus to infinity, you will get to the same answer. So basically what will happen, slowly there is some voltage difference due to which some current is flowing. Slowly the current across the resistor will become lower and lower, and it will go towards 0. The moment it goes towards 0, then all the three voltages are at same potential, which is the case that we discussed at t equals to infinity. In that scenario, the voltage will be 1 by 2 and the charge across Q2 C2 will be 1 coulomb. So 1 coulomb is your answer for the question. Switch S1 is closed at t equals to 0 seconds. Determine the maximum instantaneous voltage at node A. So at node A, what will be the maximum instantaneous voltage in volts for t greater than 0? So after t greater than 0, what is the maximum voltage that we'll observe at node A? They are asking us the voltage at node A. So before going into t greater than 0, let us discuss in the past what is happening in the past for t less than 0. If you want to know more about inductor circuits, you can. If you have no idea, you can watch this video where I have discussed about inductors in detail, the transient concept of inductors, right? Here I will just explain the solution. So we will see this determine the maximum instantaneous voltage, but first let us draw the circuit for t less than 0. So if I draw the circuit for t less than 0, I observe that I have a 1 ampere current source. Here I have inductor, the other switch is open simply. Here I have 1 volt and here I have 1 ampere, right? So this is the circuit, correct? Now the thing is, it might happen that we have kept this inductor at t equals to minus infinity. So initially the inductor may have 0 amperes of current, but as I am directly connecting a current source in series with the inductor at t equals to minus infinity, what will happen? A impulse voltage will be developed. All those things have been explained in this particular video. So you can go and watch this if you don't understand anything. So due to the development of the impulse voltage, the inductor will instantaneously change its current at t equals to minus infinity to be 1 ampere. And from minus infinity, it will remain at 1 ampere only because there is no change in the current, right? Current is constant. If current is constant, the voltage across the inductor, that is dIL upon dt, is simply 0. So for inductor to reach steady state, the current should be constant and the voltage should be 0. So voltage will remain at 0. No problems, right? T less than 0, t equals to 0 minus, right? So what will be the voltage at this point at node A? Node A, the voltage would be right now 1 volt because this is simply short circuit. So this 1 volt will come across the left hand side, right? So node A voltage right now is 1 volt, but they have not asked us. They have asked us for t greater than 0. So for t greater than 0, what will happen? This switch S1, this switch, actually I can write this as S only. We don't even need to write this. Okay, fine. The switch S1 is closed, right? If the switch S1 is closed at t equal to 0, right? So if the switch S1 is closed at t equal to 0, then the circuit will be circuit would look like this. The inductor is already there. I can replace the inductor with a current source because the inductor will not try to change its current instantaneously, right? It will try to stay at the same current. And here I have 1 ampere, right? And this inductor, because initially the inductor had no current, so the inductor will try to maintain the same state, right? It will try to maintain the same state, that is no current, 0 current. And here I have 1 volt source. Now tell me, is KCL satisfying? Yes, KCL is satisfying. So does anything needs to be changed? So will some current flow through this inductor? This inductor will say, already previously I had no current, and if I apply KCL now also I don't have any current. So do I need to change my state? No. This inductor will say, the second inductor will say that I don't need to change my state. I will keep my current as 0 only. So this inductor will keep its current as 0 only. And this inductor will still keep its current same only because inductor does not want to change its current. That's how it reaches steady state. So currents across the inductor will not change. If the currents across the inductor will not change, the voltage is equals to L dIL by dt, which will be 0 only because there is no change in current. So if there is no change in current, the voltage drop across the inductors will be 0 only. If it is 0, so this 1 volt can directly come across here because this is just like a short circuit. So this 1 volt is here. So the voltage at node A is always 1 volt regardless of anything, right? So maximum value would be 1 only. Maximum instantaneous value would be 1 only because the voltage is not changing. So this will be your answer for the question.
Yeah, let's see the solution of this one. So what you need to find out, you need to find out the mass, and the definition of mass is already given. Basically you need to calculate this particular integral, which is in place of rho x y z you need to put y, and what is dv? Dv is nothing but dx dy dz. This integral you are supposed to calculate over the volume V. Okay, now what is the difficult thing in this particular question? That is making the diagram. If you are able to make the diagram, then you will be able to take the limit as well. So making the diagram is the difficult task. So let's try making the diagram, how the diagram would look like. XYZ plane we will make. Let's make Z on the upper side, on the vertical direction Z I am making. This will be x cross y, Z. This will be x and this will be y. Okay, so first they are talking about a parabolic cylinder. Since it is, first of all, everything will be happening in the first octant. Second, they are talking about parabolic cylinder. Parabolic cylinder they are talking about. That means they are talking about a particular surface. The equation that is given is z equals to 4 minus x square. Can you draw 4 minus x square? Yes, sir. At x equals to 0, the value of z will be 4. At x equals to 0, the value of z will be 4. And sir, at x equals to 2, the value of z will be, at x equals to 0, y is also 0 and z is 4. And sir, at x equals to 2, value of y and z both are 0. So this kind of parabola you are having. Now sir, it is a line only, but they are saying it is a cylinder. So yes, actually it is a cylinder only. Z equals to 4 minus x square is just a line, but it is spread for y going from 0 to infinity. That means it is spread everywhere. It is spread for y going from 0 to infinity. Till this point it is spread only. So yes, it is actually a cylinder only. It is not a line. Equation of line is given. That means they are not talking about y. So y is spread from 0 to infinity. This is what they are talking about. So it will be spread till the infinity in this manner. Okay, in this manner it is spread. Now next is y equals to 2x plane. So someone would say that sir, y equals to 2x, y equals to 2x line will be somewhat like this. Sir, y equals to 2x, it is a line only. No, it is not a line. If they are saying y equals to 2x plane, what does that mean? That means z is going from 0 to infinity. So z will be going from 0 to infinity. So this kind of plane it would be, right? Upper side also you can make, but till this point only we are making. So this kind of plane it would be. So you can see how it is cutting. I hope you are able to see that which volume is being enclosed. How much volume is being enclosed. This is one plane and another plane. I hope you are able to visualize what is the another plane. Another plane looks somewhat like this. Another plane looks somewhat like this. It is a cylinder. It is a cylinder like this. It is a cylinder like this, and in between there is a plane. In between, like my hand is cutting this cylinder. Okay, but cylinder will have circular structure. This will be circular. In the cylinder, this will be a circular structure, but here it is not circular. It is parabolic. That's the beauty of this question. This is parabolic. Z equals to 4 minus x square. Okay. So now I am pretty sure that you are able to visualize that which volume is being enclosed. How much volume is being enclosed. So everything between these two is being enclosed. So if I try to make a rough structure of the volume enclosed, then how it will look like? How it will look like? It will look somewhat like this. That sir, here there is this parabola, and here there is this y equals to 2x line. So this much volume is being enclosed. I hope you are able to visualize it. Okay, and we can join this line. So in between whatever the volume is there, that is being enclosed. This was your x-axis, this was your y-axis, this is your z-axis. Now what you are supposed to calculate? You are supposed to calculate y dx dy dz. So first of all, very easily I can see the limit of y. Here y is 0. If I take the strip, first I am talking about the limit of y. So if I take the strip here, you can see that what will be the limit of y. Here y equals to 0 and here y equals to 2x. What is the equation of this plane? Y equals to 2x, right? So y is going from y equals to 0 to y equals to 2x. So limit of y I can put from 0 to 2x. So since I have put the limit of y now the whole projection I can take on zx plane, right? Limit of y has been taken. Now I need to take the limit of x and z. So what I will do, I will take the whole volume on zx plane only. So I will take the projection of whole volume on zx plane. So how it will look like on zx plane? So I am making zx plane directly. Okay, I am making this particular surface, whatever that you can see here. So on zx plane, how it will look like? This is your, let's just say this is your x and this is your z. So on zx plane, it will simply look like a parabola. Say yes or no. This parabola you will see at x equals to 0. What is the scenario? Z equals to 4 minus x square. So at x equals to 0, the value of z is 4. And at x equals to 2, the value of z is 0. Now I need to put the limit of z and x. So what I will do, and in which area I am going? I am working in this particular area. So in this particular area, what is the scenario? What I will do, I will take a vertical strip. I can take a horizontal strip as well, but let's take a vertical strip because we are more comfortable with that. So this is your x equals to 0. It will come in under root, no? If I take that, no, sorry, this is your z equals to 0. Sorry guys, this is your z equals to 0. This is z equals to 0, right? This is z equals to 0. Here z will be equals to 0, and this is z equals to 4 minus x square. And what about the limit of x? Limit of x is going from 0 to 2. So the scenario is limit of z is coming out from 0 to 4 minus x square, and limit of x is going from 0 to 2. Along with that, here also I can see that limit of y is going from 0 to 2x. There you go. This is the question. Job done. So what you are supposed to calculate now? You are putting the limits now. First of all, in the end, which limit will come? In the end, your constant limit will come, which is going from 0 to 2. So first I am putting the limit of y. You can either put the limit of y first, or you can put the limit of z first. First I am putting the limit of y. Y is going from 0 to 2x. Y dy. This I will do. After performing this, I will put the limit of z. Limit of z is going from 0 to 4 minus x square. Limit of z is going from 0 to 4 minus x square. And after performing this particular thing, I will put the limit of x. So what you are getting here? Y square by 2. 0 to 2x. So 4x square divided by 2. So answer is 2x square. So 2x square dot dz you are supposed to do. So 2x square will be a constant value for this. Here you would have understood that how you are getting 2x square. This will be simply y square by 2. Y square by 2. So this will become 4x square by 2. This will become 2x square. Now 2x square dz. So for dz this 2x square will be constant only. Right? So 2x square I will keep aside. 2x square I will keep aside. dz with z going from 0 to 4 minus x square. 0 to 4 minus x square. Now just as you get this answer, after that what you need to do? You need to put the limit of x. X going from 0 to 2. So what you will be getting here? 2x square multiply with 4 minus x square dot dx with x going from 0 to 2. So what you are getting? X going from 0 to 2. 8x square minus 2x to the power 4 dx. 8x to the power 3 divided by 3 minus 2x to the power 5 divided by 5 with limit going from 0 to 2. So if you put 2 here, 2 to the power 3 will be 8. 64 divided by 3 minus if you put 2 here, 2 to the power 6 will also be 64 divided by 5. So 64 divided by 3 minus 64 divided by 5, that will be your answer and job done. Okay. I know it was a tough question, but tough people will get tough things correct. Right? Easy things you find everywhere. Here I am not going to give you some strawberry. I am going to let you walk on the tougher path. If you walk on the tougher path, then in the examination you will not struggle. And this is what I want. Okay, so this is the answer. It was a good question, I know, but it is not a standard question and you will not find it in any textbook. This has been framed by me only. Okay, my own creation it is. So in that manner you can see the planes and all and you can get the answer. Okay, let's go to the next one. Yeah, so this is also a good question and this is also something you are not going to find out in any textbook. So what is the scenario here? Automated load balancer routes incoming data packets to 3 processing streams. Basically, let's just say here your data is coming, here your data is coming. To this particular point your data is coming. Now this particular point will route the data in 3 paths. 3 streams you can say, or 3 paths. Paths are S1, S2, S3. Okay, let's just say one data is coming. Now the data will go to path S1. The probability of that particular thing is 0.25. Like probability of data going into path S1 or stream S1, that is 0.25. Probability of data going into path S2, the probability is 0.5. And probability of path data going into path S3, the probability is 0.25, right? Because data would either go here or here or here. So total probability is 1. Now what they are saying? Now let's read this data. Probability of failure such that it is in path S1. So what is the probability of failure such that the data has went to path S1? That is 0.04. Probability of failure such that data has went into path S2, that is 0.02. If there is a tough question, no, then this is how you need to write down. This particular thing I don't know. Now what they are asking, given that a packet is flagged as failed, that means a packet is failed, then find the probability that it was processed by S3. We know that it has failed. You need to find out the probability that it was processed by S3. This is what they are asking. So S3 divided by F, this is what they are asking. I know that, sir, it will be equivalent to probability of F, probability of S3 multiply with given S3 it is failed divided by probability of failure. This is what we are supposed to know. Now what will be the probability of failure? Probability of failure will be that, sir, probability that it has gone into S1, after going into S1 it has failed, or probability that it has gone into S2 and after going into S2 it has failed, or probability of going into S3, after going into S3 it has failed. This is something that I am supposed to calculate. This particular thing I know, yes sir. This particular thing I know, yes sir. This particular thing I know, this particular thing I know, this particular thing also I know. Only unknown is for me in the whole question, my target is only this particular thing, that it is going into S3 and failing. Given that it is going into S3 and failing, this is something that I am supposed to find out. So for that, what will be helpful? For that, this particular data will be helpful. Okay, along with that, other things are also helpful. Here what they are saying, packet arriving at the main switch according to Poisson process at an average rate of 4 packets per millisecond and are independently routed with this probability. That means at this particular point, 4 packets are coming per millisecond. So let me know at S1 how many packets are coming per millisecond. Let's just say 4 packet has come here, 4 packet has come here, then 0.25 probability is there that 4 packets will go here. That means out of 4 packets, 1 packet would go here. No, on an average 1 packet per millisecond is coming here, and on an average 2 packet per millisecond is coming here, and 1 packet per millisecond is coming here. Say yes or no? 4 packets are coming here, 1 packet here, 2 packet here, 1 packet here, because probability is 0.25, 0.5, 0.25. So 0.25 into 4, 1 packet coming here, 0.5 into 4, 2 packet coming here, 0.25 into 4, 1 packet coming here. So at S3, on an average, at S3, on an average, 1 packet is coming per millisecond. 1 packet is coming per millisecond. 1 packet per millisecond. And it is coming according to Poisson's process. What they have written? You read. Packets arrive at the main switch according to Poisson's process. Okay. Now what they are saying, let K denote the number of packets arriving at S1 in 1 millisecond. K denotes the number of packets arriving at S1 in 1 millisecond. If K is less than or equals to 1, no, then the failure probability in S3 is 0. That means if K is less than 1, if less than 1 packet is coming, if less than 1 packet less than or equal to, if less than or equal to 1 packet per millisecond comes, then no failure. At S3, everything we are talking about at S3. And if number of packets is greater than or equals to 2, then 40% chance of failure. So what is your random variable here? Random variable is K only, which is number of packets arriving. Number of packets arriving at S3. Number of packets arriving at S3. Packets arriving at S3. Now according to Poisson's distribution, what is the probability of arriving R packet at S3? What will be the probability? So the probability will be e to the power minus lambda to the power R divided by R factorial. The probability that R packets are arriving at S3, this is the probability, where lambda is the average packets, lambda is average number of packets arriving at S3 per millisecond. Everything is happening per millisecond. So lambda is the average number of packets arriving at S3 per millisecond. How many packets are coming? 1 packets per millisecond. What we are supposed to find out? We are supposed to find out P greater than or equals to 2, which could be written as 1 minus Pk equals to 0 plus Pk equals to 1, because either 0 data packet is coming or 1 data packet is coming, right? So Pk greater than or equals to 2 could be written as 1 minus 0 or 1. So 1 minus 0 data packet is coming. E to the power minus lambda is 1 only. Lambda to the power 0 divided by 0 factorial plus e to the power minus lambda to the power 1 divided by 1 factorial. What you are getting? 1 minus 2 to the power 2 into e to the power minus 1. So what you are getting? 0.264, 0.264, 0.264. So is it the probability of failure? Is it the probability of failure? No, this is not the probability of failure. This is the probability that more than 2 data packets are coming. This is the probability that more than 2 or more than 2 data packets are coming at S3. What you have find out? You have find out the probability of what you have find out? You have find out the probability of 2 or more than 2 data, 2 or more than 2 data packets coming at S3 per millisecond. What is the probability? The probability is 0.264. Now let me know that what is the probability of failure given that data packets are coming at S3? What that would be? That sir, if 2 or more than 2 data comes, no, if 2 or more than 2 data packets come, then there is 40% chance of failure. So wouldn't you multiply it 0.4 with 0.264? Did you understand this point or not? Probability of failure given that the data packet has come at S3. So probability of failure will be that sir, it should be k should be greater than or equals to 2, and that chances are 0.264 multiplied with sir, if more than 2 data packets are coming. Let's just say you are standing at S3 and let's just say 5 data packets have come, then there is 40% chances of failure, not 100%. If 100% chances of failure are there, no, then this would have been the answer. But out of this, only 40% chances of failure are there, 60% still you will get it correct. Are you able to understand this point? So 0.264 into 0.4. So 0.105, 0.105. There you go. Now I only need to put the values. This I was supposed to find out. Now I simply need to put the value. Failure given at S3. So what will be the answer? 0.25 into 0.04. 0.25 into 0.04 plus 0.5 into 0.02. 0.5 into 0.02 plus 0.25 into 0.105 divided by, okay, this is actually the reciprocal. This is actually the denominator. Numerator would be last value 0.25 into 0.105. So 0.25 into 0.105. 0.25 into 0.105 is coming out to be 0.026, right? 0.026 plus 0.25 into 0.04 plus 0.5 into 0.02. So it is coming out to be 0.046. Take the reciprocal into 0.026. So 0.56. Roughly around you are getting 0.56 as your answer. This is the answer that you are getting. Is that understandable to you? So that's the answer. 0.56 or 0.57, whatever the answer is there, whatever the option is there, you will match it. Understandable? So this was the question. It was a good question. I know these kind of questions are pretty good, but you are learning a lot of new things here. Okay, and you can check any textbook and let me know if it is from any textbook or not. So it has been framed by me only. You see a particular scenario and this is how you frame those questions. And I hope it is having a lot of things to learn. Because in probability, what are the tougher topics? What do you think? Which topics you will think it is tougher? Poisson distribution, right? Then it would be this total probability and Bayes theorem. So combining all these things, this is how you frame the question. Although language is written by ChatGPT, but input is mine. Okay, input are mine, but language is written by the AI tools. Okay, yeah, let's go and see the next question.
From the circuit shown below, identify all the elements that cannot be classified as passive element, right? So we have 4 options and like 4 graphs basically. We have to identify all the elements which cannot be classified as passive elements, right? This should be from the graphs. This should not be circuit, this should be graphs. Graphs of elements. Okay, I will update it. So also one more thing, more than one may satisfy. Obviously this is a MSQ. If you want to learn complete things about linear, non-linear, active, passive elements, you can go and watch this video. Here I've explained everything in crystal clear manner. What is linear element, what is non-linear element, what is active, what is passive element, right? So you know few concepts. What do you know? You know, sir, slope if the slope is positive, that means it is a passive element, right? You say impedance is nothing but V upon I, that is slope, basically change in voltage upon change in current. So you say impedance positive, that means passive, and you say impedance negative, whose slope is negative, like this one, this will be active. This is also passive because this slope is positive. This is also active, right? You say this one is active because its slope is negative. You will say A is active. What there was not, which cannot be classified. So you will say this is active, so this cannot be classified as passive. This is passive only because you will say slope is positive. You will say this is active, so this also can be your answer because the slope is negative. Here slope is positive, so you will say your answer is A and C, right? And you will be wrong because this thing, right, that slope must be positive for passive element and slope must be negative for active element, that concept is not completely true. It depends on the polarities of the voltage and currents given in the network, whether it will act as a passive element or active element. So this concept is not completely true. So to solve this question totally, you would also need the information about the voltage and current polarities. Otherwise, you'll not be able to comment. But then, how, sir, you have asked this question? Here, what have I asked? Here, I have asked which cannot be classified as passive. What does cannot mean? Cannot, I will explain slowly, right? So let's assume few directions. Let's assume that the VI direction of the element E is like this, right? If I assume this, then according to the first graph, I see when my voltage is positive, my current is negative. When my voltage is positive, my current is negative. So current negative meaning, if I assume my current reference current direction to be this, negative just means that it will flow, actually the current will flow in the opposite direction. So current here enters the positive terminal because voltage is positive, current was negative, so I have reversed direction to make current positive as well. So current enters to the positive terminal of the element. So if current is entering to the positive terminal of the element, that basically means what? That means it is absorbing power. That basically means it is a passive element in this region. What about this quadrant, this upper quadrant? So in the upper quadrant, what do I observe is, again, here the voltage is negative but the current is positive, right? In this quadrant current is positive, so current direction is this only. I don't need to do anything with the current direction, but the voltage itself is negative. So if the voltage itself is negative, so again I'll have to make the voltage positive. Let's say here the voltage is minus 2 volt. We don't like negative numbers. So if this is minus 2 volts, how can I write it? I can write like this as well, right? Plus minus 2 volts. I can just swap the polarity. So right now what do you observe? Current direction is like this. So again the same thing, observe the current enters the positive terminal because current will flow and then come back here only, right? So current enters the positive terminal. That basically means what? Again this has to be passive, right? This side has to be passive. Correct. Now what if, so this V and I, where this initial V and I, what if I say no, let's not assume the reference I direction to be leaving, let's assume the reference I direction to be entering. So if the reference I direction is entering the element, then what will happen? Then if you again observe this quadrant, my voltage is positive, current is negative. So voltage is positive, current is negative, so I will reverse the direction of current. So current will be plus, right? I will reverse, like current will now go upwards, which basically means that current is leaving my positive terminal. So if current is leaving my positive terminal, if current is leaving my positive terminal, that basically means what? That basically means that this element is delivering. So at the same point of time, the element can absorb and deliver power depending on the reference directions of the current and voltage. So if you want to learn more about it in detail, that's why I have told you at the starting of the video, please go and watch this particular lecture. Here I've explained everything in detail. So this element can act both as active and passive depending on the reference direction of voltage and current. So the problem with this is I cannot classify this as not passive, right? This cannot be classified because this can work as both active and passive element, right? This can work as both active and passive element. So this is not possible. Which cannot be classified. This cannot be because this can work both as active and passive element, right? Yeah, this can work both as active and passive element. Okay. Sorry, 1 second. This this can be classified as a passive element, right? This can be classified as a passive element. Why so? Because it depends on the reference direction, right? So if the directions were like this, then yes, it was working as a passive element. If the directions are like this, then it will work as a active element. So we cannot surely say whether this can work as a active or passive. But what have they asked? They have asked which cannot be classified. So surely can you tell me that this cannot be classified as a passive element? This can be classified, right? Because one reference direction tells me yes, the other one does not, but there is an ambiguity. So I cannot surely say that okay, option A, I cannot classify this as passive element. No, you're wrong, because I can, right? I have just shown you I can. So that's why option A will not be your correct answer, because there is ambiguity. What about option B? So in option B as well, you will observe the exact same thing. You will take one direction. So right now what will happen, if you assume this direction, right? So when voltage is positive, current is positive. That basically means this element will deliver the power. When voltage is negative, current is also negative. So both of them will flip the sign. Again, plus will come here. The current direction also will change. So again, current is leaving from the positive terminal. So again, the element delivers power. So this can act as an active element. What if I change the direction of the current? Reference to current, right? What if the reference direction of the current is like this? Right? Then what will happen? Then this will work as a passive element. So I cannot surely rule this out to be not passive element, right? This can be a passive element or active element, right? So this also is not a valid answer. What about C and D? So C and D will be valid answer. Why so? Because whatever you do, whatever direction polarity of current you take, right, there will be one certain case where it will work as active, and another case it will work as passive. How so? Let me explain. So let's take this direction. Plus minus field. This is my element, right? So let's look at this quadrant. When I'm in this quadrant, for this particular scenario, my voltage is positive, my current is negative, right? Current is negative, so I will reverse the direction of the current. So current enters the positive terminal, so acting as a passive, no problems. Again, assuming the same reference polarity and direction, current direction, let's look at this particular quadrant. If I look at this particular quadrant, then you'll observe that my voltage is negative and current is also negative. Both are negative. So both polarities will flip, both signs will flip. So this current direction also will change. So right now I see that current is leaving from the positive terminal. So in this region it is acting as an active element. So for same reference direction, at the same point of time, it is acting as passive and active element. So surely I can say, so this cannot be classified as passive element, right? This cannot be. There is no possibility that this can be classified as passive element, because for same reference polarity direction, I am seeing active behavior and passive behavior, right? So this cannot be classified as passive element. This has to be classified as active element only, right? Because active element can absorb both power and deliver power. Here also same thing. Whenever your graph will cross at least 3 quadrants, right? 3 quadrants. That basically means at some point of time, if you assume the same reference direction, it will work as either active and passive for the same reference polarity. So this also can work both as passive and active element. This can work, yeah, both passive and active in different regions, right? So this element cannot be classified. This element cannot be classified as passive, right? Cannot be. There is no possibility. So option C and D are your correct answer here. Right, I hope I have made my point clear. So let me summarize. We observe that we have to identify which of the following elements cannot be classified as passive elements. Cannot be. There is no possibility. this can be, right? If I assume one reference direction, then yes. If I assume one particular reference direction, then yes, it can be classified as passive element. Like this, right? If I assume like this, this will work as active, but one polarity tells me. So I cannot totally rule this out. I don't know what are the voltage polarities are there. So I cannot say that surely this cannot be. I cannot guarantee that. Here also I cannot guarantee it, right? It depends on the voltage and current polarity. They have not given to me. So I cannot surely rule this out. But I can surely rule these two out. Whatever, so you have assumed this polarity, right? So again, you assume the reverse polarity, you will observe same behavior. At one region, it will act as passive. At other region, it will act as active. So surely these two can be ruled out, right? So that's how you solve a passive and active question. So in general, the voltage and current polarity should be given. If it is not given, then you have to solve like this. You have to make assumptions and then solve, right? So in this question, option C and D will be your correct answer.
Yeah, so did you solve this question? This is taken from NPTEL assignment. Okay, just data was some data is in it, and it is completely taken from there only. So what they are saying, that initially enable bit is 0. If enable bit is 0, then what will happen? This if this is 0, this will be 1, this will be 0, and this will be 1, right? Let's just say this is your node A, this is your node B, this will be your node Y only, and this will also be your node Y only. So this is the condition for t less than 0. For t less than 0, for t less than 0, this node is at 1, this node is at 0, this node is at 1. So what we can do is that we can make node A, node B, and node Y. For t less than 0, what is the scenario? 1, 0, 1. 1, 0, 1. This is the scenario for t less than 0. For t less than 0. Sir, what about the delays and all? You are not considering any delay or anything. For t less than 0, it is very long time, no? So this is the steady state that we have reached. It was 0 for a very long time. Steady state 1 we have reached, steady state 0 we have reached, steady state 1 we have reached. Now what will happen? This will become 1 now. Enable bit will become 1 now. If enable becomes 1, this 1 comes here, this will become 0. But how much time it would take? It would take 100 nanosecond of time. Basically, at t equals to 0, enable bit has become 1. 1, NAND gate, 1 will become 0 here. But what this gate will say? Gate will say that yes, I will give 0 at my output, but I will need 100 nanosecond of time. So this will say that yes, I will give 0 at the output, but I need 100 nanosecond of time. I need 100 nanosecond of time. So it will give 0 at the output, but after 100 nanosecond. After 100 nanosecond. So at 100 nanosecond, it will go to 0. Now at 100 nanosecond, this has happened at 100 nanosecond. So at 100 nanosecond, this will receive a signal that your input is 0 now. So change your output to 1 because this is an inverter. So at 100 nanosecond, what he will say? Yes, I will change the output to 1, but I need 40 nanosecond of time more. So at this particular window, he received a message. That you need to make your output from 0 to 1. At 100 nanosecond, he received a message that you need to make your output from 0 to 1. What he will say? Yes, I will make it, but I need 40 nanosecond of time more. So where he received the message? At this particular time, he received the message that you need to make your output from 0 to 1. So what he will say? Yes, I will do it, but I need 40 nanosecond of time more. So he will make from 0 to 1, but he needs 40 nanosecond of time more. That means after 140 more nanoseconds, so 140 at 140 nanosecond, he will make the output to 1. This is 1 only, this is 0. Now what will happen to Y? Y at 140 nanosecond, this has become at 140 nanosecond. So at 140 nanosecond, this gate will receive the message that at your input 1 has been applied, so change your output to 0. What he will say? Yes, I will change it to 0, but I need 40 nanosecond of time for that. So at 140 nanosecond, he received the message. At what time he received the message? At 140 nanosecond, he received the message. He says that I need 40 nanosecond more. So I need 40 nanosecond more. So at this, after 40 nanosecond more, from 1 to 0 he will go. From 1 to 0 he will go. So after more 40 nanoseconds, from 1 to 0 he will go. So this is the scenario that is going on. Now what will happen? Now sir, this 0 will go on here, this 0 will come here. So if 0 comes here, now basically if enable is 1, let's just say this is your gate, right? If one of the input is 1 and this is the variable input, this is the input which is Y, and one of the variable is 1. For a NAND gate, one of the input is 1, other one is Y. So what will be the output? Y bar. So isn't it working like an inverter only? Yes, as of now it is working simply like an inverter with the input of y. Then another inverter is there, then another inverter is there, and then this output has been again fed back. 3 inverters are there. What does that mean? It will work as a stable multivibrator. A stable multivibrator. And what will be the time period of that what will be one time window of that stable multivibrator? What will be the one time window? One time window will be equals to TD. How much delay is there? This will have 100 nanosecond of delay. This will have 40 nanosecond, and this will have 40 nanosecond of delay. So total delay will be 180 nanosecond. So after every 180 nanosecond, the output will keep on changing. As of now, what was your output? Here output is 0, right? Here the output is 0. Now 0 will go here. This will become 1, 0, again 1. So how much time it would take? Total 180 nanosecond time it would take. So after every 180 nanosecond, the output will keep on toggling. So from 0 to 1 it will become, then from 1 to again 0 it will become, and it will keep on toggling after every 180 nanosecond time. So 180 plus 180 will become 360. This will become 540 nanosecond, and in that manner 0, 1, 0, 1 it will keep on going. Now at what time window they are asking? At 170 picosecond, or okay, it was on picosecond. Here I have written nanosecond. So you would have understood. At 170 they are asking. At 170 they are asking. Then they are asking at 350, 350, and then they are asking at 520, 520. So 101. What is your output? 101. That's the answer. 101 is the answer. Understandable? Okay. So what is the respective output? 1, 0, and 1. So it is simply working like a ring oscillator. You can call it ring oscillator, stable multivibrator, whatever you want to call it. With the time period, what is the time period? Time period actually is 180 plus 180. Time period is 360 nanosecond. So with the time period of 360 nanosecond, this stable multivibrator is working. Initially, it was a buffer only. When the enable was 0, when the enable was 0, when the enable was 0, this was becoming 1, this was becoming 0, and this was becoming again 1. It will keep on going. 1 was stable. At the output, why here 1 was stable. But just as you convert enable bit to 1, then it has become an inverter only. Now the output will keep on toggling. 1, 0, 1, 0, 1, 0 with the time window of 180 nanosecond. Okay. So at whatever the time they are asking, you just need to see that time and tell the result. 1, 0, 1 is the final output. Understandable? It was a good question taken from another assignment only, but these kind of questions, if you have decent enough practice, no, then it should be solved. If you have decent enough practice. Okay. Now this question is straightforward. Okay. These kind of questions, if they are coming in the gate examination, they will be considered in the category of easy question. I am really sorry if you messed up this question, but they will be considered as easy question only. What you need to do? Sir, what is your Q naught plus? What is the next state equation? Very easily, we just need to write down the next state equation. Here, what is coming? What is this? This is your Q2. So Q2 would come here. So Q2 into Q naught bar, Q2 into Q naught bar plus Q2 bar into Q naught, Q2 bar into Q naught. So what is your Q naught plus? That is Q2 XOR Q naught. What will be your Q1 plus? For Q1 plus, sir, Q naught is going inside. So Q naught into Q1 bar, Q naught into Q1 bar plus Q naught bar into Q1, Q naught bar into Q1. So what it will become? Q naught XOR Q1. What about Q2 plus? So for Q2 plus, Q1 bar is going. So Q1 bar into Q2 bar plus Q1 Q2. So what it will become? It will become Q1 Q2 X naught, right? So these are our next state equation. How will I write down? Q2 Q1 Q naught. Initially it is loaded at 0, 0, 0, 0. Initially it is loaded as 0, 0, 0. So from 0, 0, 0, where it will go? So what is Q2 plus? Q2 plus is the XOR of these two. What is Q1 plus? Q1 plus is the XOR of these two. And what is Q naught plus? Q naught plus is the XOR of these two. So this is how we will remember. So 0 XOR 0 will become 1. This will become 0, and this will also become 0. Now XOR of these two, this will become 0. XOR of these two, 0. XOR of these two, this will become 1. Now XOR of these two, this will become 1. XOR of these two, 1. XOR of these two, again 1. Right? Then XOR 0. Then XOR of 1, 1 will become 1 only. XOR of these two, 0. XOR of these two, 0. That means again from here to here you are going. So how we started? We started from 0, 0, 0. But then we saw that the cycle that is going as 1, 0, 0, then 0, 0, 1, and then 1, 1, 1, and then again to 1, 0, 0. This is the cycle that is going on. 1 0 0 0 0 1 1 1 1 and then again 1 1 0. So this will be the output after first clock cycle. First, this will be the output after second clock pulse, and this is the output after third clock pulse. This will be the output after fourth. This will be the output after fifth, and this will be the output after sixth. This will be the output after ninth, 12th. In that manner, it will keep on going. Right? That means the number which is divisible by 3, the number which is divisible by 3, after that clock pulse, if they are asking, then this will be the output. So what I mean to say is that after at 99th clock pulse, what will be the output? After the 99th clock pulse, after 99th clock pulse, this will be the output. So after 100th clock pulse, what will be the output? This will be the output. So what is the answer? 100. 100 is the answer. That's it. Right? First, second, third. So simply what you do is that 100 divided by 3. What is the remainder? Remainder is 1. So after first clock pulse, what is the output? That is the output. So answer is 100. 100 will be the output. Understandable? Very easy question. These kind of questions have been asked like 20-30 times in gate examination. Okay. So easy questions should have been solved. Let's go to the next one. Yeah, this one, Vs by I naught, we are supposed to find out. So this is your current I naught. This current is also I naught only. Now let's assume this as ground. Any node I can assume as ground. If this is your Vs, then this will become your Vs. And if this is your Vs, this will become your Vs. How much current this will drive? Here input current of op-amp will be 0 ampere. This current will also be 0 ampere. If this is your Vs, this will also be Vs. Why is that so? Because there is negative feedback. So this will drive Vs by 2 current. Vs by 2 current. From the upper side there is 0 ampere current. That means the complete Vs by 2 current will flow here. The complete Vs by 2 current will flow here. The scenario is that this is your 2 ohm. This is your 2 ohm. And this is your 3 ohm. From the upper side there is no current. Here what is the current? Vs by 2. What is the potential here? Potential is Vs. This is your 3 ohm. So the same current Vs by 2 will be flowing here. Vs by 2 will be flowing here. Now Vs by 2 into 3. How much will be the potential? 1.5 Vs. How much will be the potential drop? Vs by 2 into 3. 1.5 Vs. If this node is Vs, this is 1.5 Vs. So this node will become 2.5 Vs. This node will become 2.5 Vs. Now 2.5 Vs is connected with 4 ohm. 2.5 Vs is connected with 4 ohm. So how much current they are driving? 2.5 Vs divided by 4. 2.5 Vs divided by 4. 2.5 Vs divided by 4. And from here how much current is coming? From here I naught current is coming. Right? So what do you see here? I naught current is equivalent to how much current is flowing in 4 ohm resistance? Sir, in 4 ohm resistance 2.5 Vs by 4 current is flowing. And here how much current is flowing? Vs by 2 current is flowing. Vs by 2 current is flowing. So I naught current is equivalent to Vs by 2 plus 2.5 Vs by 4. So you are supposed to find out Vs by I naught. So from here what I need to do is that I will put I naught equivalent to 0.5 2.5 by 4. .5 by 4 plus 0.5. Take reciprocal. What we are supposed to do? We are supposed to find out Vs by I naught, no? Vs by I naught. So I naught, this will become 0.5 Vs plus 2.5 by 4. 2.5 by 4 plus 0.5. So this will become 1.125 Vs. 1.125 Vs. So what will be Vs by I naught? That will become 1 upon 1.125. So from here you get the answer. Vs by I naught will become what? Let's take the reciprocal. 0.888 we are getting. So 0.89 would be the possible answer. Okay. So possible answer is 0.89. Simple network analysis concept. Vs current here, Vs current here, Vs by 2 current here, 2.55 Vs by 4 current here, I naught current here. So Vs by I naught current we are supposed to find out. Answer is 0.89. Okay. Done. Yeah. Hi guys. So let's solve this question. So we need to talk about the negative feedback in the circuit. So what we will do? We will increase the output. If this output increases, then what kind of configuration it is? If I talk about this configuration, what kind of configuration it is? It is inverting amplifier, right? Or you can see that, sir, if this node increases, then this node will increase. And if the negative node increases, then the output will go down. So this will go down. Or you can directly see that, sir, it is an inverting amplifier. Like this is the inverting amplifier, no? It is the inverting amplifier. This is the scenario. So if this node increases, which is your V node, if this increases, then what will happen? This will go down, because what is the gain of inverting amplifier? That is RF by R1 into V naught. Although here it should be V in and this should be V naught, but it is opposite here. So if this node increases, then this node goes down. And if this node is going down, then this node will also go down. Right? If this node is going down, then this node will also go down. Now if this node is going down, What you want this node to go down only. You want this node to go down only. Why is that so? Because you want negative feedback. No, negative feedback means output should be settled, right? Output should not be unstable. So if you are increasing your output by a small amount, this is decreasing by a small amount, this is also decreasing by a small amount, this node is also decreasing by a small amount, and you actually want your output to decrease only, that means B has to be positive, A has to be negative. Because in the op-amp, we already know, in op-amp, what do we know? In op-amp, I already know that if I increase this potential, then output will increase. If I decrease this potential, then output will decrease. This is known as non-inverting terminal. And what about this one? If I increase this potential, then output will decrease. And if I decrease this potential, then output will increase. Because it is inverting terminal, right? So what really happened? B has to be positive and A has to be negative. So for the circuit to operate under negative feedback, terminal A should be the inverting one and B should be the non-inverting one. B should be the non-inverting one. B should be the non-inverting one and A should be the inverting one. Right? Now secondly, what we need to do? We need to find out the gain. We need to find out the output value for input value to be 5 volt. So if this is 5 volt, then how much current is there? 1 milliampere current is there. If this is 1 milliampere current, then here also there is 1 milliampere current. And if this current is 1 milliampere, then how much drop will be there? 25 volt will be the drop here. So 5 plus 25, what this will become? This will become 30 volt. Someone would say that, sir, from here as well 1 milliampere current will flow. No. Output of op-amp can drive some current. No. This can drive some current. How much current it is driving, that we don't know. But you cannot say this current will be 0. Input current will be 0. But this current would be finite, right? So 1 milliampere here, 25, 30 volt. Now this node is 0, this node will also be 0. So how much current is flowing here? 30 divided by 40. So this current would be 3 by 4 milliampere. So you can directly see here that, sir, this current is 1 milliampere, this current is 3 by 4 milliampere. That means from the output of the op-amp, 1 plus 3 by 4, which will be 7 by 4 milliampere current would be coming. Although it is not asked to find out, but this also we can find out. So this is 0, 30 by 40, 3 by 4 milliampere. Now here there will be 0 current, no? In this terminal there will be 0 current because input of the op-amp will drive 0 ampere current. So this current would be 0. So complete 3 by 4 milliampere current will be flowing here. Complete 3 by 4 milliampere current will be flowing here. So how much will be the drop here? 3 by 4 into 5. 3 by 4 into 5. 15 by 4. That will be nothing but 3.75. So here the drop will be 3.75. So what is the output potential? So this node is 0. So output potential will come out to be minus 3.75. So minus 3.75 volt will be the output. That's it. Okay. It was an easy question only. I hope you were able to solve. If your concepts are clear about the op-amp, then these kind of questions are not tough. Okay. Let's go to the next. Yeah. So this question I would say this is the easiest question of a whole question paper. Okay. Because even the class 12th guy can also solve it. From where you are starting, your initial state is 100, 100. This is your initial state. So what is the input sequence? Input sequence is 1. So if the input sequence is 1, this is where I will go. Then the input sequence is again 1. So if input sequence is 1, then this is where I will go. Then now input sequence is 0. So if the input sequence is 0, then this is where I will go. That means you are again at 0, 0, 0. Then again the input sequence is 1, then again here I will go. Then now again the input sequence is 1, then again here I will go. So 1 is there for 2 more times. Then again input sequence is 1, here I will go. Again input sequence is 1, here I will go. Right? Then input sequence is 0. So where I will go? For input sequence to be 0, there I will go. Then input sequence is again 1, then here I will come. So answer is 1, 1, 0. I'm not sure whether I counted it again or not. So it's just up to you only. Like how you need to do. Let's get started again. That you are at here. Input sequence is 1. Sorry, how input is coming? Input is coming 1, so here I will go. Then input again is coming 1, so here I will go. Then input is coming 0, then here I will go. Input is coming 1, then here I will go. Then input is coming 1 for 3 more times. So input is coming 1, input is coming 1, and then again input is coming 1. Then input is coming 0, then again it is coming 1. So yes, your final state is 1, 1, 0. This is how you need to analyze. Just have some patience and get the answer correct. Very easy. No FSM design, nothing. Simply you need to tell that if this is the input, then what will be your final state, which is 1, 1, 0. That's it. Okay. Let's go to the next question. Okay. I need to change the video.
In the given circuit, 2 ideal ammeters each indicate a current of 8 amperes, and the directions are obviously shown. The total power absorbed by all the resistors are absorbing power, which is 3200 watts. Determine the value of R2 expressed in ohms. So you have to determine the value of R2. So this question is pretty straightforward. They're simply asking us the value of R2. How do I calculate the value of R2? So if I'm able to find out the voltage across R2, let's say V2, and the current through R2, let's say I2, then my job is done. So V2 by I2 would give me R2. But how do I calculate the voltage across R2? Or if somehow I am able to calculate the power across R2, that will be equals to I2 square into R2. So I need two quantities, either current, voltage or power, any three quantities, any two of the three quantities. So I know this thing, they have already told me that these currents are 8 ampere, right? According to the direction. So 8 ampere is coming here, 8 ampere is coming here. So from here 16 amperes should flow. So the current across the current through the current source is basically 16 amperes. Okay, that we know. Do we know anything else? Now this current is 16 amperes. What else do we know? Now these ammeters are idle. If these ammeters are idle, we can hold on a second. We can replace these ammeters with simple short circuits, right? Simple short circuit. So this current is 16, and from here 8 amperes current is flowing in. From here 8 amperes current is flowing, right? So what do you understand from that? Now there is no element that is delivering power. Only we have one active element, that is this ammeter, and we know all the resistors are absorbing 3200 watts of power. So obviously the power delivered will be equals to the power absorbed in a circuit, right? Power delivered will be equals to the power absorbed in a circuit. So what is the power delivered? The power delivered will be equals to 3200, because absorbed power is 3200. And who is delivering the power? Obviously this current source is delivering the power, right? So if I assume a voltage across this current source as V, so this will V into I would be equals to the total absorbed power, that is 3200. I already know the value of I value 16, we have already found that out. So your V value would be equals to 32 divided by 16, that is nothing but 200 volts. So your V value comes out to be 200 volts. So I got the V voltage, that is 200 volts. I know the current through this resistor, right? That is 8 amperes. Do I know the resistance value? Of course I do, right? So this is simply V by R. So V voltage is 200 across this resistor. The voltage is simply 200, right? And I is 8. So the resistance value would be 200 by 8. So this would be, if I divide by 4 on both sides, so 50 divided by 2, that is 25 ohms. So resistance R1 is 25 ohms, but they have not asked me the resistance R1, they have asked me the resistance R2. So one thing do you notice, that from this side equal current is coming, from this side also equal current is coming, right? And this is the ideal ammeter, so we can replace ideal ammeter with short circuit. If you don't understand that, you have to go and watch my network theory videos. There I have explained what does an ideal ammeter mean, what does an ideal voltmeter mean. That's why this particular picture is there. You can go and watch this playlist in our PrepFusion Hindi channel. Okay, so right now what will happen is this resistance is 25, so from this side as well we'll observe 25 ohms, because both of them have to be equal, then only current will be divided symmetrically. All these concepts I have explained in my lecture series. So this, if I see the resistance from here, the resistance should be same as 25. So basically 100 parallel with 50 parallel with R2 should yield me 25 ohms, right? So what is 100 parallel with 50? So 100 parallel with 50 would be 100 into 50 divided by 150, that is nothing but 100 divided by 3, right? So it is 100 divided by 3. So 100 divided by 3 is in parallel with R2. So 100 divided by T in parallel with R2. 3R2 divided by 3 equals to what? Should be equals to 25. So 3 will be cancelled. This 25 will be, this will be 4. So your 4R2 equals to 100 plus 3R2. So your R2 comes out to be 100 ohms. Right? R2 comes out to be 100 ohms. So your answer would be 100 ohms. 100. This will be answer for the question. Consider a linear network containing a load RL as shown, right, between terminals AB. The following observations are made with this load RL, right? when Vs is 0 and Is is 0, RL is replaced by a 10 volt source with terminal A taken as positive. The resulting current I is equals to -1. So basically the I, right, this current flows in this direction as -1. So what information does it give to you? If I'm applying a voltage here and if I'm making the source current to be 0, source voltage to be 0, this is a linear circuit containing resistors only. If I apply a voltage here, I get a current of 1 ampere, that is leaving, right? -1 basically means +1, like in this direction, right? I equals to -1, I will just reverse the direction, right? So basically it means I'm applying a voltage source, I'm measuring the current to be 1 ampere. So the resistance seen from this terminal A and B will be equals to what? It will be the voltage applied, that is 10 upon the current leaving out from the terminals, that is 1. So this will be 10 ohms. This is the resistance between A and B, and this is basically my what? Thevenin's resistance. Very important information that might be useful later on. So I'm keeping this information for me, right? Next, what they're telling me that when Vs is 20 volts and Is is 10, the load resistance RL is replaced by 2 volt voltage source in series with a 2 ohm resistance. Okay, so okay, when the voltage here, this is 20 and this current is 10 ampere, the load resistance is replaced by 2 volt voltage source and in series with the 2 ohm resistance with terminal A taken as positive basically for the voltage source. The resulting current is I equals to 1. So resulting current becomes 1 ampere. Now what they're telling me, for the given circuit, the source values are now Vs equals to 30 and Is equals to 20. So determine the maximum power that can be transferred to the load resistance RL expressed in watt. Okay, so basically what they're telling me, if I'm changing for the given circuit, if I'm changing the source voltage to be 30 and 20, then what will be the maximum power that can be transferred to the load resistance RL? If I connect a load resistance RL, then what will be the maximum power? Very confusing question actually. So first they're telling me that if I connect 20 volt voltage source and 10 ampere current source, and if I connect this particular load, then I observe that the current is 1 ampere. What information will that give me? So we know RTH, I know Vs and Is. How will I? So I need to determine the maximum power that can be transferred to the load resistance RL. So what is the formula for maximum power? Do you remember it? So this is simply a linear circuit containing resistance only. So we have to deliver, if I have to deliver the maximum power to any load resistance RL for this particular case, then I have to find out I have to calculate the VTH, right? If you remember the maximum power transfer theorem, it was VTH whole square upon 4 RTH. I'm just simply using the formula, but there is a derivation. If you want to go through the derivation, you can go through my lecture series. You will understand that. I'm not deriving it. So I have to find out, I know RTH. I have to find out VTH for this particular case. How do I calculate the VTH? It's very interesting. How do I calculate the VTH? So let me draw the circuit. Like, what is the scenario right now? The scenario is, if I replace this whole network with a simple VTH and RTH, I can do that. And here is my load. So in this scenario, when my voltage is 20 volt and my current is 10 ampere, then, and if I replace my load, right, this RL load with this, the current that I get is what? What is the current? The current is 1 ampere. The current that flows into the load is 1 ampere. So can I use this? Can I write the KVL equation here? So what is my load? So let me replace the things, right, with the known stuff. VTH, I don't know. RTH is 10. This will not change, right? RTH will be same. Load is simply a resistor of 2 ohms with 2 volt voltage, right? And I know the current, that is 1 ampere. So I can simply apply KVL and I can calculate my VTH. I can calculate my VTH. So VTH will be simply equals to this 10 into 1. You can simply apply KVL plus 2 into 1 plus 2, right? So VTH would come out to be 14 volts, right? This is what my VTH is equal to. Now, how will I calculate VTH in this scenario? Because VTH is calculated for 20 volt and 10 ampere as the current and voltage, right? But I am changing the voltage and current to 30 volt and 20 ampere. So the VTH will change. All these concepts I have taught you in my lecture series. So please go through it. You will understand and learn a lot more concepts there, right? You will understand and learn a lot more concepts there. So what will happen? How will I calculate? So your VTH, right? Your VTH will be a function of your input, obviously all the independent sources, that is X into Vs. X will be some any random number and Y into some Is, right? So I know for one condition that my VTH is what? VTH is 14. I don't know what is the value of X. We have to calculate that, right? When my Vs is what? Vs is 20 and when my Is is 10. But I have to calculate my VTH when my Vs is 30, right? Vs is 30 and Is is 20, right? Okay, I think there is a slight typo. This Vs should not be 30. My bad. Otherwise, we'll have, because we have only one equation. Sorry, this should have been 40. Okay, I'll fix this. I'll fix this in the question. This should be 40. So this will be actually not 30, because if it is 30 volts, we'll never be able to solve this because I have one equation and two unknowns, right? I will not be able to solve it. That's why. So this will be 40. Now, can I get any relation? If I just simply multiply this particular equation by 2, I will get my actual VTS, right? Basically, what is happening? You're scaling your voltage and current in the same proportion, so your VTH also will be scaled in the same proportion. All these stuff I have taught in my lecture series. I will not explain here every single thing. So that's why your VTH will be doubled. So your VTH will become 28 volt. Now your VTH is 28 volts. Your VTH is 28 volts. You have to determine the maximum power. We have all the information right now. We know what is the VTH for this scenario. We know what is the RTH. So the maximum power transfer would be PL max would be simply VTH square, that is 28 square upon 4 into RTH. RTH is simply 10, right? So upon 40. So let me calculate this particular value. 28 square upon 40, which comes out to be 19.6 watts. So your answer would be 19.6 watts for this particular question. In the given network, each branch has resistors R. The equivalent resistance between A and B is given as X into R. Right? Each of these branches have resistance R. They are not shown in the symbol, but they are all R. Determine the value of X. Right? So for finding out X, I first need to calculate RAB. How do I calculate RAB? So I have taught this method in my lecture series. So if you want to learn about finding out equivalent resistance in detail, you can go and watch this particular lecture in my PrepFusion Hindi channel. Right, so here I will just quickly tell you how to solve these kind of circuits. Whenever this infinite kind of circuit is there everywhere, right, always try to assume, always try to take a current source and try to solve this using superposition. How do I solve this using superposition? So what do I need to do? Let's assume that I have a current source, right? Let's assume that I am connecting a current source of I, right? If I am able to calculate the voltage across this current source VAB, then my VAB by I will give me the RAB. But how do I calculate the voltage across the current source? What we can do is we can break this down. I can assume that I am connecting a current source between node A and ground, right? So let me break it down. In the first case, I will connect a current source between node A and ground. Now you will say, sir, how? So this is infinite network, right? So current needs to come back to ground. Where is the path? Where is the closed loop here? Where is the closed path? I will explain. just for a second, let's assume that current will come back here, just for a second. If I observe when the current I comes in this node, so I'm only considering case 1 where I have connected the current source at node A and ground, right? I will consider the case 2 as well, and I will calculate the voltage VAB in both the cases, right? So first I will calculate the voltage VAB in this scenario. So basically what will happen, I will consider two cases, right? First, when the current source is between node A and ground, there I will get a VAB. Let's assume that as VAB dash, and then I will consider the current source between node B and ground. There also I will get a VAB. Let's assume that as VAB double dash. And your overall VAB would be the sum of these two, because I'm just using superposition here. I'm simply using superposition, nothing else, right? Okay, because basically I can assume these two current source to be like this only, right? This I. So first I'm considering for this current source, then I'm considering for this current source, assuming I have a ground between them, right? That's it. That is what I'm doing. This is what I'm doing. That's it. Nothing else, right? So how to solve this basically? First of all, let's assume for the case 1 where the current source is entering node A. So because this is infinite network, right? I have nothing else, right? So on all the four sides, I'll observe equivalent resistance, right? Same resistance. So if I observe same resistance, so if I current is incoming, I have 4 paths to leave. So this current will be I by 4, this current would be I by 4, this current would be I by 4, this current would be I by 4, right? I have 4 paths, 4 equal paths. So all the 4 currents will be I by 4. Now again, the moment I will reach here, or let's say I reach here, right? I have 3 equal paths, right? 3 equal paths, because again I'm seeing infinity, infinity, infinity. Like both of them, all 3 of them will, I will observe same resistance. So again the current will be equally divided in 3 parts. So this will be I by 12, this will be I by 12, and this will be I by 12. And like this it will go on. Current will keep on dividing. And after a certain point, what will happen is the current will become 0. So when the current becomes 0, we can assume that as, so the voltage drop is 0. So if the voltage drop is 0, that has a potential of 0, right? So basically what is happening towards the end, right? All of this is ground. So current will, so this node potential and this node potential will be same and they will be connected. So that's how the current is returning. So at infinity, at the ends, these are becoming virtual grounds, right? Because the voltage drop is 0. That's how the current is returning. Because few students might have doubt, so how the current is returning. Current is returning like this, right? But our purpose was to what? Our purpose was to calculate VAB dash. So can I calculate VAB dash? Certainly I can. VAB dash would be potential difference between these two resistors. So simply apply a KVL like this, right? I have to calculate VAB. What will be VAB dash? It will be simply this current into the resistance, that is, this resistance is R. Each branch resistance is R. So R into I by 4 plus this drop, that is I by 12 into R. Right? So this will be basically I into R divided by 3. What about the case 2? So in the case 2, it is just the opposite, right? I have a current I that is coming out of the node B. So that's how all these currents will become I by 4, I by 4, I by 4. Same concept. No, nothing is different. I by 4. Again, there will be same division. I by 12, I by 12, I by 12. Again, you calculate VAB. What will be VAB? VAB double dash. This will be the drop across this resistor, that is I by 12 into R. I by 12 into R plus drop across this resistor, that is I by 4 into R. This is the same as IR by 3. So this VAB dash is also IR by 3. So your VAB would be equals to what? VAB would be equals to IR by 3 plus IR by 3. So your VAB by I would be equals to 2 R by 3. That is equals to your RAB. and your RAB is equals to x into r. So your x comes out to be 2 by 3, that is 0.67. This will be your answer for the question.
Yeah, so let's solve this question. Now if you don't know what do you mean by polar curves, then there is a problem. Okay, you can watch this video. This video you need to watch, polar curve and their calculus. This video you should be watching. Okay, if you want to understand what is the meaning of polar curves, how will you draw it on xy plane, that you don't know, then there is a problem. Okay, how will you draw 2 cos 2 theta? It is known as 4 petal curve. Okay, so 2 cos 2 theta on xy plane, this is how it will look like. On xy plane, this is how it will look like. At theta on this line, theta will be equals to 0. On this line, theta will be equals to pi by 2. Here theta is pi and here it is 3 pi by 2. So this is how we will do it. When theta is equals to, and what is the meaning of r? R is the radial distance from the origin. Okay. So when theta is 0, the radial distance from the origin is 2. When theta is pi by 4, then the radial distance will become 0. So basically, when you make the diagram, no, then this is how it will look like. I am already making it. So it will be symmetric about origin and 4 petals will be there. 4 petals symmetric about origin. This is how it will look like. Okay, this distance will be 2 to 2 only. This is how it will look like. Now what we are supposed to calculate? We are supposed to calculate f, that means on this path I need to walk. I need to move on this path. I need to move on this path in the counterclockwise direction. This is what they are asking me to do. Okay, so basically in the counterclockwise direction. So in this direction I need to move. In this way I need to move on this particular path. Okay, in this way I need to move in the counterclockwise direction. So f dot dr I am supposed to calculate. F dot dr. So can I replace it as del cross f dot ds? Because what is the area it is enclosing? This is the area it is enclosing. It is a very good question. You will learn a lot of new things here. Del cross f dot ds. What will be my ds? So ds vector I can directly write down since it is in xy plane only. So dx dy k cap coming towards me because anti-clockwise direction, so coming towards me. So dx dy k cap. Del cross f I need to find out. So you can do the del cross f on your own. What del cross f you will be getting? Sir, when I find out del cross f, no. So sir, del cross f I will be getting is k cap x square plus x square y cube plus x e to the power y square plus x cube sin y. This is what I will be getting. This is the del cross f you will be having. Now what you are supposed to calculate? Del cross f dot ds. So when you calculate del cross f dot ds, so what will happen? K cap dot product with k cap will become 1 only. So eventually what you are calculating? Eventually what we are calculating is I, this function which is x square plus x square y cube plus x e to the power y square plus x square sin y, and ds is dx dy. Right? This is what we are supposed to calculate over the region R. Now I don't know whether you know this concept or not, but in the calculus I have told this concept again and again, that if your region R is symmetric about origin, if your region R is symmetric about origin, so in vector calculus I have told this concept, if it is symmetric about origin, symmetric about origin. So what is the meaning of symmetric about origin? So if I say that in my region one point which is x comma y exists, then sir for sure another point which will be minus x comma minus y, that will be also existing. So yes or no, if it is symmetric about origin. So if x comma y is existing, then f of minus x comma minus y will also exist. So what we will do is that we will take a particular function, like this is our f of x comma y, this is our f of x comma y, this is our f of x comma y, f of x comma y. Basically here you are supposed to calculate 4 different integrals. No, first one is this one, second one is x square y cube dx dy, third one is x e to the power y square dx dy, x e to the power y square dx dy, and the last one is x square sin y dx dy. So how will you calculate so much of integrals? 4 integrals you are supposed to calculate over the surface, over the region R. How will you calculate all these integrals? So sir, if the region R is symmetric about origin, then what you need to do is that in place of x you put minus x, and in place of y you put minus y. And if your function, if this particular function, if this particular function, this particular function, this particular function, this particular function is coming out to be equals to minus of f of x comma y, no, then its double integral, it's a double integral over the region R will be 0 only. You can take any example and you can check it as well. So let's check out, let's check dropping this one, let's check this one. Let's just say my function is f of x comma y is x cube, x square y cube, x square y cube. Now in place of x I put minus x, in place of y I put minus y. What I will be getting? X square here, minus y cube will be minus sign outside. So isn't it coming out to be minus of x comma y? Basically f of minus x minus y is coming out to be minus of f of x comma y. What does that show? That means this particular integral dx dy over the region R will come out to be 0. You will see a lot of your PYQs, no? A lot of your PYQs can be solved using this simple property. There is a property for x-axis as well, that if your region R is symmetric about x-axis, so this is how it will be symmetric, no? Let's just say this is your region R. Is it symmetric about x-axis? Yes, sir. This is my x-axis. This is my y-axis. So is it symmetric about x-axis? Yes, sir. So if plus y is existing, then surely, sir, minus y will also exist. If in the region plus y existing, then minus y will also exist. So what you will do is that in your function, in place of y, you will put minus y. And if your minus sign is coming outside, then what you will see is that for sure your f of x comma y dx dy will surely come out to be 0. Why is that so? Because, sir, when I am integrating for x comma y, then whatever the result that I am getting, I will get the same result but in the negative direction for f of x comma minus y. Whatever the result that I am getting for f of x comma y, that, sir, I will get the same result but in the negative direction for f of x comma minus y. So they will cancel out each other. It is like an odd function. It is like your odd function. If your f of minus x is equals to minus of fx, then you know that f of x dot dx from minus a to a will be 0 only. So similar thing we are doing here. So this is when you are symmetric about x-axis. So when you are symmetric about x-axis, you know that, sir, y will be also exist or minus y will also exist. So what I will do is that I will check at f of x comma minus y. If minus sign is coming outside, it will be 0. And if it is symmetric about y-axis, then you would know what you will be doing. So, sir, plus x exists, that means minus x will also exist. So in place of x, you will put minus x y. So minus sign will come outside. And simply double integration you do, this should come out to be 0. Okay, well and good, understandable. So, but if it is symmetric about origin, then what you will do? If it is symmetric about origin, that means, sir, if f of x comma y is present, if f of x comma y is present, then minus x comma minus y is also present. So what you do is that in place of x you put minus x, in place of y you put minus y. If minus sign is coming outside, then this would be 0. So similar thing would happen with the other functions as well. What is the other function? Other function is x e to the power y square. X e to the power y square. So in place of x, I will put minus x. In place of y, I will put minus y. What I am getting? Sir, negative sign outside I am getting. What does that mean? Simply that, sir, this will also be 0. This is already 0. Along with that, this will also come out to be 0. Why is that so? Because, sir, let's just say I take my function as h of x comma y, which is x square sine y. X square sine y. If I put minus x minus y, what I will be getting? So this will become x square only. Sine of minus y, which will be nothing but sine y, minus sign will come outside. This will be the answer, which is negative of this. What does that mean? That means this integration will also come out to be 0. So what you are left with? You are left with only this much of integration. So over this surface, over this given surface, you are supposed to calculate, your answer has reduced to only this much, x square dx dy. This is what you are supposed to calculate over the surface R. And can you calculate it? Yes, sir. On the surface, x will be r cos theta, dx dy will be r dr d theta. R is going from where to where? Sir, r is moving from 0 to, from where to where r is moving? R is the radial distance from the origin. So r is going from 0 to till this surface. So r is moving from 0 to 2 cos 2 theta. R is moving from 0 to 2 cos 2 theta. And theta is moving from, in the whole region, theta is moving from 0 to 2 pi. Theta is moving from 0 to 2 pi. On polar curves, in GATE 2023 question have been asked. Okay, in previous year as well question have been asked, and I am pretty sure in one of the branch in GATE 2027 as well, one question is coming from polar curves. I am telling you today I am telling you from polar curves in one of the engineering branch. I don't know, it could be mechanical, civil, for sure one question from the polar curve, from this particular topic, it is coming. For sure it is coming. I'm telling you today only. 1 month, 537 views. You check the content once. You will realize if it, forget about it. I will not discuss it here. But yeah, people don't appreciate this content. You find out any book and let me know if these kind of things are written anywhere. Like, I have read the book, then so much of discussion I would have done. I would have solved so many of question. What do you think? Does it click to me directly? X square y cube. I would have solved so much of question. No, using x equals to r cos theta, y equals to r sin theta. I would have put it here, r d r d theta. Then these conclusions came out that if your region is symmetric about origin, if your region is symmetric about x axis, y axis, then what will happen in your double integral? So immense level of effort is there. But 537 views for this in 1 month. And people go on teaching like this dx dy you calculate and you take a strip. This is the vector calculus. This is the calculus they teach, that you take the strip x to, this is the range of pi. This is the calculus they will teach, and they will get 50,000 views, and here 500 views for this content. This is just one video. I'm telling you, watch the complete calculus. You will realize what is the actual meaning of engineering calculus. What you study, that taking the strip like this and this is the calculus is done. This is the meaning. Have you ever understood the meaning of curved surface area and all? I'm pretty sure like those you guys would have completed the calculus. Don't take me wrong, okay? I am not being arrogant here, but you guys would have completed the calculus and you don't even know the meaning of double integration. I'm telling you, a lot of guys are there. You would have solved the PYQs as well. Sir, every PYQ we were able to solve, but you don't even know the meaning of double integral. I can tell you. What does it represent? What does it represent? Does it represent the surface area? Because double integral we are doing, it is a surface area. A lot of things are there. Okay, that was not a surface area. That was actually the volume. So just like I hope anyone is not feeling offended, but yeah, just I noticed these number of views and what kind of content is there, what kind of effort I have put in this video that I remember, and in other videos as well. But views are not coming, then what I can do? What do you think? I will frame my question paper in an easy manner that you take a strip and get the answer correct. I will not frame this kind of question, and this question have been framed by me only. If there is anyone who can find this question in any textbook that you have taken from this textbook, then let me know. Complete full content, full question is framed by me. Although the words are of ChatGPT wrote it down, but I dictated. Right? So this kind of effort is there. I don't know when people will appreciate. Forget about it. So this is what we are supposed to calculate. X dx dy r d r d theta are going from 0 to 2 cos 2 theta. Theta is going from 0 to 2 pi. This is what we are supposed to calculate. So we are supposed to calculate the integral I. Theta is going from 0 to 2 pi. Then people goes on saying that if you can afford the money, then you should go for this 80K course, which are given by this particular institute, that particular institute. If you can afford the money, buy this 80K course, okay? And let me know if they are providing anything better than this 10K course. Whatever they provide, no. If they provide X, I provide 5X. This I can guarantee. Today I can guarantee. Okay, you call it arrogance, whatever you can call it. If they are providing X, no, I provide 5X. Whether it is the quality of the content or student support, doubt solving support, test series, whatever it is. People think that if you are having the money, then you should go here. If you are not having the money, then you come here. If money is the criteria, if they for this content, if they deserve 80K, so then surely I deserve 4 lakh. But I'm keeping the price 10K. I'm not saying that 4 lakh price I should keep. No, this is absolutely wrong. Even this price is also wrong. To be very honest, education should be free. Government should be funding us. Government should be giving me money to teach you like that. But government will give you the money. The government will give the money to the professors who does not teach anything in the government college. Here I put up all the level best, give my all effort. Then government will say, and the media, government media, they will say that we are do coding teachers and we take money from the students after giving all these efforts. Okay. So the price will be always less than 10K only. But here, like this I will be never able to understand that if you are having the money, then you go for this course. If you are not having the money, then go for this course. Money and all never is the concern. If you know the content that they provide, EDC is completely free, maths is always running, network analysis as of now in Hindi it is running, EMFT is completely free. Watch the content and match with 80K. Let me know if they even come nearer. Okay. And my student promote my course, that I know. They always promote my course. I never ever paid a single rupee. Like this I can say on PrepFusion that I never ever paid a single rupee for marketing. Never ever, not a single rupee. I never ever asked anyone, to go and make the comment, or I hired a PR team make the comment. Never, not a single rupee. And I'm never going to invest as well. Not a single money for the paid comments. I always say one thing: watch my content and let me know how it is. And once you watch it here, then forget about anyone else. Yeah, sorry for bringing all these things. I just this thing triggered me actually. I just noticed this and it triggered me actually. Sorry for that. Sorry for wasting your time. You can skip this part. It is internet. I am not wasting your time in the offline class. Okay, it is internet only. So if you don't want to hear my these things and all, although during the lecture I don't do these kind of things. I always teach during the lecture. My always concentration is that if this is the 3 hour of lecture, I need to bring the level best out of me. So that concentration I never break. But here, making the solution, it got broken. Because in our Telegram group only, I have seen this kind of comment that if you can afford 70k 80k then go for this branch. अरे भाई कुछ नहीं है भाई, 70,000 80,000 लेके तुम लोगों को लग रहा है कि 10 सालों से वो पिछले 30 सालों से पुराना इंस्टीट्यूट है. That institute is established in 1989, in 1990. That means they would be teaching something remarkable. I won't even let them come even nearer. Forget about competing. I might be way worse than them. Okay, they might be way better than me. I don't care. You treat them way better, but I'm never comparable to them. Okay. Yeah. I know arrogant comments are coming out. So like people, I have seen people saying as well that all the coaching institute provides same kind of content. It depends on the student. Surely it depends on the student, but all coaching institute provide same kind of content. Yes, they provide. PrepFusion is different. We don't provide the same kind of content. We might be even worse than. We might be even worse than them. They are way better than us. It is acceptable to me. But equal to them, comparable to them, or nearer to them, never. I am never nearer to them. Either I am way ahead or I am way backward. Never nearer. Okay? Never ever nearer. It is what it is. Okay? You might feel offended, whatever it is, but it is what it is. That we are never same. Okay? We are not the same. Either ahead or backward. But never the same. 0 to 2 pi. I'm sorry if I offended anyone. I respect everyone. Okay, I respect everyone, but respect should be mutual, right? Respect should always be mutual. So I will always respect everyone. It's just that I have the confidence on my content, and this is what I'm saying. I'm not taking anyone down. So what we are getting, 4 cos to the power 4 is coming outside. 0 to 2 pi. This was r to the power 3. So this will become r to the power 4 divided by 4. Limit of r going from 0 to 2 cos theta. Then 16, this 4 is coming outside. So this will become cos to the power 4 theta, cos to the power 6 theta we are getting. Cos to the power 6 theta. Now what kind of graph you will be getting for cos to the power 6 theta? Sir, this is a even power. Sir, since this is a even power, then all the negative part will become positive part only. What does that mean? That means, sir, this could be broken into 0 to pi by 2 and 4 can come outside. Now for this concept, what people will teach? A lot of theorems, no? Like you take pi minus theta, then you check this one, that thing. Simply you would go by the graph. Cos to the power 6 theta. This is the graph of cos theta, right? From 0 to 2 pi. Now you are supposed to integrate cos to the power 6 theta d theta from 0 to 2 pi. Now sir, I don't know what will be the nature of the graph, but I know one thing that, sir, if there is an even power, no, then whatever the negative value is there, that will become positive value. So rough nature I can make in this manner. From 0 to 2 pi. Right? So this is from 0 to pi by 2. This is from pi and this is from 3 pi by 2. So sir, whatever the area I will be getting from 0 to pi by 2, no, the same area I will get from pi by 2 to pi, the same area I will get from pi by 2 to 3 pi by 2, and the same area I will get from 3 pi by 2 to 2 pi. That means, sir, 4 times of area 0 to pi by 2 I will be getting, and this is how I can break it down. That's it. And if there was even power, if there was cos to the power 5 theta, then what would have been the answer? Then you would know that, sir, negative will remain negative only, positive will remain positive only, and sir, you are integrating from 0 to 2 pi, then sir, positive area will cancel out the negative area, answer would be 0 directly. So no theorem, nothing. All these things in the comprehensive course I have completely explained, and I am providing everything for free on internet so that people watch it, so that people see that what is the meaning of content. People don't even know engineering here in this field, teaching for last 30 years. I should not be making these comments. Let's end this question as early as we can. Okay. People are so arrogant, they think that what they teach, but they don't know the reality. I hope you know from 0 to pi by 2 cos to the power 6 theta d theta. How do we do it? 6 comes downward, 2 you need to subtract, then 1 more subtracted, 5 into 3 into 1 divided by and multiply with pi by 2. So what we will be getting? 4 into 2, this will be 2 only. 4 into 2 into 2, this will get cancelled out. So answer we are getting 2.5 pi. Is that so? Is there any calculation error or anything? Let me check. Okay. What was the input? 2 cos 2 theta was the input. Okay, 2 cos 2 theta was the input. Here the input was x would be r cos theta only. This is dx dy. 2 cos 2 theta. This limit is 2 cos 2 theta. Sorry guys, this is 2 cos 2 theta. Look, this is what happens. This is 2 cos 2 theta. Sorry for all these things. I'm really sorry. This should not have happened actually. 2 cos 2 theta it is. Okay, this is 2 cos 2 theta. Now you need to solve this integral. So this integral is actually very good. This is not very straightforward because it is 2 cos 2 theta. So just 1 second, I will drink some water and then we will solve this integral. Okay. Yeah, welcome back. So did you solve this one? So what we will be getting? Here I will put 4 will come outside, right? And this will become cos to the power 4 2 theta cos square theta d theta, right? Now theta going from 0 to 2 pi. Now this is the integral we are supposed to solve. What do we know? Cos 2 theta equals to 2 cos square theta minus 1, right? If I put 2 cos square theta minus 1, then I will do the power 4 here and then I will have to open it, right? This is how the integral will go because it is cos to the power 4 2 theta, right? So this is how the integral will go, and doing the power will be very difficult. So this is not a good method. We need to think of something else. What we can think? Cos to the power 4 2 theta is there, right? And cos square theta is there. We need to make either everything in 2 theta or everything in theta only, right? Here angle is 2 theta, here angle is 2 theta, here angle is theta. We need to make either the whole function in 2 theta or the whole function is in theta only. This is what we need to do. Cos square theta. What is the formula of cos square theta? Cos square theta could be put as 1 plus cos 2 theta divided by 2, right? So this is how cos square theta could be put from 0 to 2 pi cos to the power 4 2 theta 1 plus cos 2 theta divided by 2. Yeah, now we are talking, right? This is what we can do. Now what we can do? Let's keep this 4 aside and let's call this as I1. I will solve the I1 and then I will simply multiply with 4. So I am supposed to solve the I1. What is I1? Sir, I1 is nothing but 0 to 2 pi, 0 to 2 pi, cos to the power 4 2 theta divided by 2, cos to the power 4 2 theta divided by 2 d theta plus, because 1 by 2 I am multiplying inside, this will become cos to the power 5 2 theta divided by 2 theta, cos to the power 5 2 theta divided by 2 d theta, right? Cos to the power 5 2 theta divided by 2, cos to the power 5 2 theta divided by 2 dot d theta, with theta going from 0 to 2 pi. Are you able to understand this point? What is the time period of cos 2 theta? Like one cycle it will cover when theta is, look, this is the graph of cos 2 theta I am making. This is the graph of cos 2 theta. This is theta equals to 0. And here theta will be equals to pi. No, I am making the graph of cos 2 theta. Cos 2 theta graph I am making. Because at theta equals, when theta is pi, it will become cos 2 pi. When theta is, what will be this angle? This angle will be nothing but pi by 4 only, no? Sorry. Yeah, right. This angle will be nothing but pi by 4 only. Why is that so? Because cos 2 into pi by 4, it will become cos pi by 2. Basically, if there is a signal xt, which is having a time period of t, then what will be the time period of x of 2t? That will become half of it. What I mean to say is that, what is the time period of cos theta? That is 2 pi. Because cos theta repeats after every 2 pi. Then what will be the time period of cos 2 theta? That will become 2 pi by 2. That will actually become pi. So this window will be pi actually. Are you able to understand this point? And this will be 2 pi. Now you are doing cos to the power 5. So if you do power 5, then sir, positive area remains positive only, negative area remains negative only, and you are integrating from 0 to 2 pi. That means you are integrating for 2 cycles. So positive area is completely getting cancelled out by negative area. This is positive area, this is positive area, which will be cancelled by this negative area, this positive area, this negative area, completely cancelled out, and this will be equals to 0. Positive area will be completely cancelled out by negative area. What about this one? Sir, here what will happen is that here power 4 is there, no? So negative area will become positive area here. So that's the thing that will happen here. Right? Understandable? So what I will do is that I will assume 2 theta as t. So what I will get, d theta as dt by 2. Okay, so when theta is 0, this will be 0 only. When theta is 2 pi, this will become 4 pi. Cos to the power 4 in place of 2 theta divided by 2, in place of d theta divided by 2. This is what I will be getting. So 1 by 4 goes outside. From 0 to 4 pi, cos to the power 4t dot dt. Now I am supposed to draw the graph of cos t. So this is how the graph of cos t would look like. But power 4 is there. Always remember what this will be. This will be 2 pi. I am drawing the graph of cos t. And remember, power 4 is there. Power 4 is there means, sir, negative area will become positive area. 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 Right? And this will be your 4 pi. So from 0 to pi by 2, whatever the area I get, no, the same area I will get from pi by 2 to pi as well. The same area I will get from pi by 2 to 3 pi by 2 as well. In that manner, sir, if I need to take this outside, so how I can take it outside? Sir, total 8 area I will get. What I need to do is that, can I write it down in this way? Because, sir, from till 4 pi, how many boxes of pi by 2 would be there? Pi by 2, pi by 2, pi by 2. Till 4 pi, how many boxes would be there? So total 8 boxes would be there. So 8 you have taken outside. So 8 into 0 to pi by 2 cos to the power 4t dt. This is what we are supposed to calculate. So this will become 2 here. Multiply with, here 4 is there, divided by 2. 4 minus 1, 3 pi by 2. So what you are getting? You are getting 3 pi by 8. So when you solve the integral, you are getting 3 pi by 8. So this integral is giving you 3 pi by 8. 4 into 3 pi by 8. What is the answer you are getting? 3 pi by 2. 3 pi by 2 is the answer you are getting. Now someone would say that, sir, you are taking roughly around 25 minutes for the explanation. Although 5 minutes I wasted. Sir, you are taking roughly around 20 minutes for the explanation. So this kind of question will never come in the examination hall. Yes, this kind of question will never come in the examination hall. But how many content you have learned from this question? Although you don't know how to make this graph, for that you will have to watch this video. I cannot explain everything in one video only, right? So how many things you have studied from this particular question only? First of all, this particular thing you have studied, that if it is symmetric about origin, if it is symmetric about x-axis, if it is symmetric about y-axis, then how to deal. So who knows in the examination only this is coming. So very easily you will be able to write down the answer as 0. Only this is coming. You very easily will be able to write down the answer as 0. And who knows if this is coming, then you will not write down the answer 0 and you will solve it in this way. So how many things you have done? Then you have understood this single integration as well. That how you will deal with cos 2 theta. How you will deal. This is how you will deal. So a lot of things you have studied here, no? A lot of things about integration. So from one question, how much things you are learning? So isn't it a great quality problem? People will say it is irrelevant, but is it actually irrelevant? Right? Okay, then let's meet in the next question. Yeah. So here S1 set is given, S2 set is given. You need to find out the geometric area of the intersection of S1, S2. What is S1? S1 will consist of all the vectors, all the 3-dimensional vector. S1 will consist of all the 3-dimensional vector whose length, what is this? This is the length of the vector, no? Because you do x transpose x, what you will be getting? You will be getting x1 square plus x2 square plus x3 square. So this is actually not the length of the vector. This is the square of the length of the vector. So this is the square of the length of the vector. So what will happen is that S1 will consist all the 3-dimensional vector. S1 will consist all the 3-dimensional vector. All those 3-dimensional vector. Where if I take the square of this one, take the square of this one, and take the square of this one, and add all of them, it will come out to be less than 24. What I mean to say is that in S1 will you get 1 1 1 1 as well? Yes sir, surely I will get 1 1 1. Why is that so? Because sir, if I put 1 1 1, then 1 square plus 1 square plus 1 square, that will be 3, which is less than 24. Yes, I will get 1 1 1. Will you get 1 0 1? Surely I will get. Will you get 0 1 0? Surely I will get. Right? So it will span a complete space R3. Right? So all the 3-dimensional will be, all the 3-dimensional vectors will be available whose length is less than 24. What it is representing? So it has a dimension of 3. What it will represent? It will represent a volume. volume of what? In 3D, it will represent a volume of a sphere whose radius is under root 24. Did you understand this point? Like basically what they are saying, they are saying only one thing. If I make a 3D coordinate system with x1, x2, x3. So your vector is, your one vector is x1, x2, x3. So I have made a 3D coordinate system. This is my x1, this is my x2, and this is my x3. So all the vectors which has the length less than under root 24, less than under root 24. This is square here, no? So all the vectors who is having length less than under root 24. So let's just say this is the length which is less than under root 24. This is the another length which is less than under root 24. So maximum length it can have under root 24. Let's just say this is the maximum length. It can have under root 24. This is the maximum length. This can have under root 24. This is the maximum length. It can have under root 24. This is the maximum length it can have. This is the maximum length it can have. Rest all other length will be lesser than this. So whatever, all the vectors which are coming inside this, they will be included in the span of S1. So what is the span of S1? Span of S1 is the sphere. Span of S1 is a sphere in 3D. A sphere in 3D whose radius, like basically the maximum length that it can cover. This is the maximum length it can cover. This is the maximum length it can cover. This is the maximum length that it can cover. That will be under root 24. And it is not a circle, it is actually a sphere. So how will I show the sphere? This is how I can show the sphere, that I will make another line here somewhat like this. This is how I will show the sphere. Okay, so it is not a circle, it is a sphere, it is a 3D sphere. So this is the geometric representation of S1 I have made. The S1 vector set, the S1 set, or what you can say, the S1 vector space can be represented by a sphere of volume, V, which is having a radius of under root 24. Say yes or no. Next what we need to do? Next we need to take the subspace S2, which is somewhat like this. 1 1 0 0 1 1. That means S2 will have these two vectors and all the linear combination of these vectors. These two vectors and all the linear combination of these two vectors. So what is the dimension of S2? Can anyone let me know what is the dimension? The dimension of S2 is 2 dimension only. Sir, although that vector is of 3 dimension, but sir, here there are only 2 linearly independent vectors. They are linearly independent, no? 1 1 0 0 1 1. Yes, they are linearly independent. So there are only 2 linearly independent vectors of 3 dimension. The vectors are of 3 dimension, but there are only 2 linearly independent vectors. I hope you know the concept of vector space, then only you will be able to understand this concept. Otherwise, you will not be able to understand. Okay, so you need to study vector space, then only you will be able to solve this kind of question. Okay, so the span is 2 dimension, but the length is 3 dimension. Vectors are of 3 dimension. They will be spanning a 2D space. That means they will be making a plane. And I hope you know this concept that 0, 0, 0 will always be a part of S2. Why is that so? Because you can take the linear combination. Let's just say this is vector A and this is vector B. So linear combination of vector A and vector B will belong to S2 for sure. If I put alpha equals to 0, beta equals to 0, then surely 0, 0, 0 will belong here. So what it is representing? It is representing a 2D plane. The plane will be passing through 1, 1, 0. It will be passing through 0, 1, 1, and it will be passing through 0, 0, 0 as well. Say yes or no. So there will be a plane which is passing through all these points. This does not matter to me, but I know one thing, that my plane will be passing through 0, 0, 0. So the dimension is 2 dimension. It will be spanning a 2D space. Which will be passing through 0, 0, 0. So it will be a plane which is passing through 0, 0, 0. So how it would look like? What do you think? How it would look like? It would look somewhat like this. It will be passing. Look, making a picture will be difficult here. I hope you are able to understand that this was your sphere. This was your, what this was? This was your S1, right? This was your S1. This pair was your S1. This pair was your S1. Now what I am doing is that from here one plane is passing, which is passing through the center. One plane is passing like this, which is passing through the center. So what will be the common surface area between them? If I cut it from here, and I ask you what is the common surface area, what is the intersection of S1, S2? This was your S1, this was your S1, and this plane is your S2. This plane is your S2. And if a plane is passing like this, then what is the common intersection part? That will be a circle of radius under root 24. This will represent a circle of radius under root 24. Do you agree to this point? What was S1, sir? S1 was having all the three-dimensional vector whose length is less than under root 4. That means, sir, it will represent a volume of radius under root 24 and it will represent a sphere as well. Right? Now, sir, you are talking about a three-dimensional vector who is spanning a 2D space. Three-dimensional vector who is spanning a 2D space. That means it will be a plane. It will be a plane which will be passing through 1, 1, 0 and 0, 1, 1 and surely 0, 0, 0. Someone would complain that, sir, what if the plane would have passed from here? Then, sir, it will be the common area would be a circle only, but radius would have been different. But for sure, my plane will pass from the origin, and if the plane is passing from the origin, then what will happen? What it will cut? It will cut a circle like this. I hope you are able to visualize. If it is passing from the origin, then it will cut a circle like this. And what is the radius of the circle? That is under root 24. And what you are supposed to find out? You are supposed to find out that geometric area. What will be the area? Area will be pi r square. So answer will be 24 into pi. 24 into pi you can calculate, and that will be your answer. That you can do on your own. Answer will be 24 into pi. Is that understandable to you or not? There is a sphere. S1 is a sphere. What is S2? S2 is nothing but a plane only. Why it is a plane? Why S2 is a plane? Because a three-dimensional vector which is having two independent vectors. Three-dimensional vectors, and a vector space is having only two independent vectors. That means the span is 2D, no? So the span becomes 2D. 2D span means it is a plane which will be passing through 0, 0, 0 for sure. And you need to find out the intersection. That means the plane is passing like this, and this is your S1 and this is your S2 which is passing from inside. So what is the intersection? Intersection will become a circle with the radius of under root 24. It is a gate PYQ actually. Okay. People think that paper is irrelevant. It is a gate PYQ. In previous year only it has come. Either in, I guess it has come in CSE or in which branch, I don't remember. But it is a gate PYQ. Ditto same. Here just they wrote down the language that S2 be a subspace of R3 with the dimension 2. So there they told it is a dimension 2. Here I am asking you to find out the dimension. Here from here like two independent vectors are there, so you can directly say it is 2 dimension. There they have given that it is having a dimension of 2. Gate PYQ. Okay, gate PYQ. So people think I never ever frame anything irrelevant. If I was framing irrelevant, no, then I would never be giving the video solution. I would have given the text solution. But if I am having the guts of giving the video solution, if I am having the guts of explaining all these questions, that means I actually teach all these things. Then I have the guts of providing the video solution. No, otherwise people can frame a tough question paper from standard book. They will pick up some question, lengthy calculation would be there. That will not make any sense. But every question is based on intuitions. This was also based on intuitions. This was also based on intuition. Every question is based on intuitions. Are you able to understand this point? Although in this question there was lengthy calculation, I agree. But in other questions, is there any lengthy calculation here? No. Under root 24 is the radius. If it is passing, then one line calculation is there. Only one line calculation. In this question, was there any calculation involved? No, no calculation. Just you need to see the current and get the answer. Here, any calculation here. Very lesser calculation. Although in maths, yes, there was some calculation involved. But yeah, I hope you are able to appreciate this level of questions. Okay, let's go to the next question.
Let's solve this question. Determine the amplitude of the sinusoidal current expressed in amperes for the circuit shown below, right? So what do I mean by amplitude? So if I have a current, sinusoidal current, I of t, some Im sine omega t plus phi, then this value, this Im value the magnitude of Im basically is known as the amplitude. So I have to compute the amplitude in this scenario, right? What do I notice at the starting, right? Both of these are basically same frequency. If both of these are same frequency, what is the impedance provided by them in complex domain? So this impedance would be basically minus j by omega into c. So minus j, omega is 1, c is 0.25. So that is minus 4j. What is the impedance provided by this? This will be j into omega L, that is j into 1 into 4, that is 4. So this is providing minus 4j, this is providing plus 4j. So essentially these two are simply short circuited, right? So it is just like resonance. This is the condition of simple resonance, right? Resonance circuit. So technically I can read out the circuit like this. So 5 sine omega t here, sine t, and here I have 12 cos t, and this is 1 ohms, right? So I have to find out this current. So I of t would be equals to what? This node potential, right? Actually I should have drawn the instantaneous polarity, although it does not matter, because still I will draw the instantaneous polarity things, otherwise we'll mess up. Okay, so basically this current will be 5 sine t minus 12 cos t divided by 1. So if I convert this in phasor domain, right, if I assume these two are my reference, so I'm talking about the concept of phasors, this will be 1 angle 0. So what will be cos? So if you remember, my cos is here, sine is here, right? All these I have taught in my network theory AC course. I will not explain everything in detail. So if I assume sine to be my reference, how much angle do I need to add to reach to cos? I need to add plus 90, right? Plus 90. So because sine cos theta is equals to sine 90 plus theta. So this will be basically, if I assume this to be my 1 angle 0, this will be 1 angle plus 90, right? Not 1, sorry, this will be 5 angle 0, and this will be 12 angle plus 90. I am assuming this amplitude to be my magnitude here of the phasor, right? You can assume anything. All these I have taught in my AC network theory course. So this will be basically 5 angle 0 minus 12 angle 90. 12 angle 90, 5 angle 0 is nothing but 5 only, and 12 angle 90 is J12, right? Minus sign is there, divided by 1. So this is 5 minus J12. If I write this in proper format, the magnitude would be 5 square plus 12 square under root, and angle would be what? Tan inverse y upon x. So y is minus 12 and x is plus 5, right? So tan inverse minus 12 upon plus 5. Again, your y is negative and x is positive. That means I'm lying in the fourth quadrant. In fourth quadrant, the angle comes out to be negative. So I don't care about this angle. I don't care about this angle really. So this will be 13. This will be some angle phi. I don't care about it, right? So magnitude is 13, and we have assumed that what does magnitude mean? Magnitude basically means the amplitude of the resultant waveform. So the amplitude will be 13. This will be your answer for the question. They have asked for amplitude of the current, so that would be 13. I don't care about the angle. You can calculate the angle tan inverse minus 12 by 5, but that is not our concern. So answer of this question will be 13 amperes. For the given linear two-port network, the ABCD parameter matrix is this, right? T is ABCD like this, and this is the two-port network linear, and the ABCD parameter matrix is this, right? For this linear network. Now they're reconnecting like this, and then they're telling me that the ABCD parameters for this whole network, right? V1, because V1, I1, all these things are marked here properly. For this whole network, the ABCD parameters are this. Now they're asking me the value of A into B divided by C into D. So basically they're asking me to find out the ABCD parameters of this linear network and then compute this particular value. So we know in ABCD parameter, two networks, if they are cascaded, their ABCD parameters will be simply equals to matrix multiplication. Let's assume this as network A. Let's assume this as, or let's assume this as network X. Let's assume this was network Y, right? So this is the network Y basically. So this will be Tx into Ty. The whole ABCD parameters will be equals to the matrix multiplication of the individual ABCD parameters. This I have taught in my AC lectures in the two-port network chapter, right? So this value is this, right? but I need to calculate Tx and Ty, because this is what I need to calculate, because from this I will get the value of A, B, C, D, and Ty I can calculate from this network, right? It's pretty simple. I've already taught this, the shortcut of calculating the ABCD parameters in my full course. So please go and watch that. This will be 1 plus Z2 upon Z1. What is Z2? Z2 is this, right? And Z1 is this. So Z2 upon Z1, that is 2 upon 2. And on the right hand side, I will have Z2. This will be 1 by Z1. Plus this will also be 1, right? There is a set formula. You can manually calculate. You can calculate in slow manner, no problems. But in my full course, I have taught this in detail in the formula. You can go and watch that particular lecture, right? Two-port networks, ABCD parameter, okay, in English channel. So the value would come out to be 3, 2, 1 by 2, 1. You can solve this without formula, no problem. It will just take you more time. You can calculate the ABCD parameter individually of this network, no problem. But it will take you more time, right? So 3 to 1 by 2, 1. Okay, this is the, so not 3, sorry, this is 2 by 2, right? So this will be 2 only. 2 to 1 by 2, 1. Okay. Okay. I know this, right? So I know Ty, I know capital T, so I need to simply calculate Tx, right? Tx would be equals to what? Tx would be equals to, Tx is nothing but my A, B, C, D, right? This one. I can simply do the, multiply the inverse on both sides, right? Ty inverse. Then I will get Tx. So let me take the inverse of this. What will be the inverse? So there is a shortcut to calculate inverse of 2 cross 2 matrix. So I have to swap the main diagonal elements. This you will learn in mathematics, and I have to add a negative sign with the off diagonal elements, right? And then divide by the determinant. The determinant is simply 1 in this case. 2 minus 1 is 1 only. So determinant is 1. So that won't change anything. So this will be the inverse, right? Inverse of the network Y would be 1 minus 2 minus 1 by 2, 2. So again, if you don't know how to calculate inverse, study it, you will realize that, yeah, this comes out to be exactly this only, right? So I'm using a shortcut to calculate the inverse. If you don't understand it, use it using a normal method. So this will be equals to, now I already know what is capital T, that is 3, 2, 1. I know what is Ty inverse, that is 1 minus 2 minus half 2. Okay, so this will be equals to what? So 3 into 1, that is 3 only, plus 2 into minus 1, that is minus 1 only, right? Minus 1 by 2, basically minus 1. Then this will be 3 into minus 2, that is minus 6, and 2 into 4, that is plus 4. This will be 1 into 1, that is 1. This is 1 into minus half, that is minus half. This is 1 into minus 2. This will be 1 into 2, that is plus 2, right? So this will come out to be 2 minus 2, 1 by 2, and 0. Right? So this is your A, B, and okay, there is a problem. There is a huge problem. Your D comes out to be 0. I never thought about that. Okay. Maybe I should change. I should change what needs to be asked. This is a bummer. So let me change it. I'm extremely sorry. I actually did not thought this through. So because I was also solving this. So let us calculate A, B by C plus D. Right? This should be a good number. Let's ignore this particular thing. Right, sorry about that. So A into B is minus 4 basically. So 2 into minus 2, this is A, this is B, this is C, this is D, right? So A into, so 2 into minus 2, that is minus 4, divided by C is 1 by 2, plus D, that is 0, right? So this will be minus 4 into 2, that is minus 8. So minus 8 will be your answer for the question.
Yeah, so let's see this question. This is a latch, okay? So a random latch, if a random latch is given, what is the way of analyzing it? In the lecture, I have already told you. Now, if you don't know, then let me tell you again that if there is any random latch is given, like they will make any random circuitry, any combination circuit they have used, and this is a random latch, how will you analyze? You will do one thing, that one of them you will assume as Q. So in latches, you would know that you design the circuitry in a manner that, sir, here this will be your input. One of the output will be Q, then other output has to be Q bar. So one of the output you will assume as Q, and other one you will assume as Q bar. This is how you analyze any random latch. Okay, based on the input AB. So what all AB could be applied? Sir, only two inputs could be applied, and based on that, sir, we will get these outputs. So this is how you analyze it. This is how you analyze any random latch. Okay, and questions have also come on random latches as well, like SR latch, NAND latch, NOR latch. All these latch we already studied. JK latch, D latch. These are the standard latch, but this is a random latch. So how will you analyze a random latch? That I am telling you. So write down all the inputs. You always remember that this is C and this is D. Okay, write down all the inputs 0, 0, 0, 1. These are the possible input. 1, 0, 1, 1. Now apply 0, 0 here. If I apply 0, 0, what will happen? Sir, if I apply 0, 0 here, then do I know the output already? Like, do I know the value of Q already? No. What you will say? Sir, I don't know the value of Q already. Why is that so? Why is that so? Because sir, 0, it is a OR gate. OR gate cannot give the output based on 0 only. So what he will do? What will be this particular scenario? This will be Q and this will be Q bar, right? Because it is an inverter. So Q bar, this will become Q and this is Q only. So Q will go here. This will become Q bar here, right? And this Q bar will go here. This will become Q here. So what will happen? Q bar plus 0 will be Q bar only, and then again bar. So what answer you will be getting? If you are applying A as 0, then here you are getting Q, and if you are applying B as 0 here, then this is your Q bar. Q bar goes here. This will become Q only. Q plus 0. This will be Q only and Q bar. This is what you are getting. What is this condition? This is the hold condition. This is the hold condition. So this is how you actually analyze. Okay. Next you are applying A as 0, B as 1. A as 0 and B as 1. A as 0, B as 1. A as 0, B as 1. So if I applied B as 1, then I already know that sir, this output has to be 1 only. No matter whatever the condition is there. If B is 1, then this has to be 1 only. And if this is 1, then this has to be 0 only. What does that mean? That means Q bar has come out to be 0. Then you don't need to analyze this one. You will simply write down if this is 0, this will be 1 only. There is no other chances because they are complement of each other. No. So no analysis of this one. If it is a latch, if it is a valid latch, then if this is 0, this has to be 1 only. No analysis, nothing. Next, if you are applying A as 1, if you are applying A as 1, if you are applying A as 1, then you know that sir, if this is 1, then this has to be 0 only. And if this is 0, this has to be 1 only. So your Q is coming out to be 1. अरे भाई ये क्या हो गया? If A is 1, then this will be 1 only. No, sorry guys. If A is 1, then this has to be 1 only and this has to be 0 only. So A is fixed coming out to be 0. If it is fixed, no, then this has to be 1 only. This has to be opposite only. Here, why I analyzed in both of the way, Q and Q bar. Why I analyzed both of the ways? Because not a single output was fixed. But here this output was fixed. Here this output is fixed. So one output if you get fixed, then other will be complemented of that. What about 1 1? What about 1 1? If you know that sir, both are 1 1 only, both are 1 1 only, that means both outputs are fixed this time. This is 1, this is 1. So 1, this has to be 0, this 1, sorry. If this is 1, then this has to be 1. If this is 1, this has to be 1. If this is 1, this has to be 0. If this is 1, this has to be 0. 0 0 will come, and this is an invalid condition. So this is hold condition, this is invalid condition, and these are the conditions as per you. So if you are considering C as the output, then this button will become set and this will become reset, right? So all these things they did not ask, but what they are asking that your output is 1, 0, C, D is 1, 0. This is your output. Then what is your possible input? Someone would say that sir, answer is 0, 1. This is the only answer. This is one of the possible answer, but other answer would also be 0, 0 is also possible answer. This was a MSQ question. 0, 0 is also a possible answer. Why is that so? Because what they are asking, the possible values of input AB is. So let's just say my output has already come. This is my output, no? So let's just say my output has already come at. So the scenario was that I applied A as 0 and B as 1. So what really happened? This output has already come 0 and this output has come 1 only. So when I applied 0, 1, output was 1, 0. Now what I did, I changed the input from 0, 1 to 0, 0. What will be my output? My output will hold the condition. So output will remain the same. Q will be Q only, Q bar will be Q bar only. So when I applied 0, 1, my output was 1, 0. Now I change the input. I apply the input to be 0, 0. Output is still holding the condition. No. That means if my output is 1, 0, what is my applied input? Applied input would be 0, 0 as well. That means this answer is also possible and this answer is also possible. Are you able to understand this point? Two answers are possible. Assuming that first I applied 0, 1. So my output came out to be 1, 0. Now I change the input to 0, 0. What is my output? 1, 0 only. Now what question is saying? That your output is 1, 0. What is your possible input? Someone would say that, sir, I applied actually 0, 1. And someone would say that, sir, after applying 0, 1, I have applied 0, 0. So two possible inputs are possible. No. With the input being 0, 0, is it possible to get output 1, 0? Yes. With the input being 0, 1, is it possible to get output 1, 0? Yes. So both answers will be accepted. It was an MSQ question, that's why both answers are accepted. Listen to the statement again very carefully. If my applied input is 0, 1, is it possible to get 1, 0? Absolutely, sir. If my applied input is 0, 0, is it possible to get 1, 0? Yes. If your previous state was 0, 1. And what they are asking? Possible value. Possible value. Possible value means if there is only single case, then also you need to take. Someone would argue that, sir, what if my previous state was 1, 0, then output would have been 0, 1. Now I change the state and apply 0, 0, then output will be, sir, 0, 1 only. But they are asking the possible values, no? So possible values might be 0, 0 as well. So two answers will be accepted. Okay, understandable? So this was the trick in this question, that hold condition will also be accepted, because who knows, you might have applied 0, 1, then you would have got 1, 0, then you change the input and keep it 0, 0 only. So if you are only looking at the output, then it might be possible that input is 0, 0. Understandable? Let's go to the next question. Yeah, so let's solve this question. This is not a very tough question. If your concepts are clear, no, so not a very tough question. Like from here to here, if you go, how many phase shift you will get? 180 degree. Then from here to here you will go, another 180 degree you will get. Now let me know from here to here, if you go, from this node to this node, if you are going, how much phase shift you will get? 180. No. What is the transfer function of this particular circuitry? Like, let's just say if this was my node X and this is my node Y. So what will be my Y by X? My Y by X would be, can you write down the transfer function? It will come out to be -1 upon SRC plus 1. So what is the phase it is having? It is having a phase of 180 degree minus tan inverse omega RC. So it will give you a phase of 180 degree, 180 degree and 180 degree minus tan inverse omega RC. And I hope you know the transfer function of this particular circuit. Like let's just say this is your, this is Y only, no? And let's just say this output is Z. So from Y to Z, how much phase shift you will get? From here to here, tan inverse minus tan inverse omega RC. From here to here, again minus tan inverse omega RC. From here to here, again minus tan inverse omega RC. So this particular circuitry will give you the phase shift, total phase shift of -3 tan inverse omega RC. Okay, so 180, 180, 180. So total phase shift you are getting is 180, 180 will get cancelled out. This will become 360. So this will become 0 phase shift only. So total phase shift you are getting is 180 degree minus 4 tan inverse omega RC. Is that understandable to you? You can find out the transfer function of this one. You would got that you are getting 180 degree minus tan inverse omega RC. A lot of people would have done this mistake, that they would have written 180 degree phase shift only. But actually you are getting 180 degree minus tan inverse omega RC. You need to write down the transfer function. If this capacitor was not there, no, then you would have said that if capacitor was not there, then the transfer function would be -1 only. Then you would have said that, sir, yes, now there is a shift of only 180 degree. But if capacitor is there, then the shift is 180 degree minus tan inverse omega RC. So this is the total phase shift that you are getting. It has to be equals to 0 degree. This is your requirement. So from here what you are getting, 4 tan inverse omega RC would be equals to 180 degree. That means tan inverse omega RC should be equals to 45 degree. That means omega RC should be equals to 1. So what is the value of omega? That is 1 by RC. So what is the frequency of oscillation? That is 1 by RC, and these values are given. That will come out to be 1 radian per second. So this was the first question, that you need to find out the frequency of oscillation. What is the second question? The second question was, you need to find out the value of RD. All these values are mentioned. RS, GM, all these values are mentioned. You need to find out the value of RD. So two conditions are there for sustained oscillation. That first phase shift should be 0 degree, and other one is that total gain in the circuit from here to here, total gain in the circuit should be equivalent to 1. So I need to find out the total gain to be equivalent to 1. So let's get started from here to here. If I move from here to here, how much gain I am getting? GMRD. Then if I go from here to here, how much gain I am getting? GMRD upon 1 plus GMRS. GMRD upon 1 plus GMRS. Then I would have reached at this point. So if I have reached at the point X, then how much gain I have got? From the first stage I have got GMRD, and from the second stage I have got GMRD upon 1 plus GMRS. Then from the next stage, how much gain I will get? From the next stage, sir, I will get this much gain. I am only talking about the gain, okay, not the sign. Phase shift we have taken into action. So I will get 1 upon J omega, S could be replaced as J omega RC. So we will get 1 upon J omega RC plus 1. So you already know, sir, 1 upon, from this circuit, how much gain we are getting? 1 upon 1 plus SRC. 1 upon 1 plus SRC, that could be equated as 1 upon 1 plus j omega RC. What is the value of omega? Omega value is 1 by RC. So what you are getting? 1 upon 1 plus omega value is 1 by RC, so 1 upon 1 plus j. So what is the gain? 1 by under root 2. So from this one stage you are getting the gain of 1 by under root 2. So how much gain are you getting? 1 by under root 2. Now from here to here, from z to y, if you are going, how much gain you are getting? Again you are getting 1 upon cs upon 1 upon 1 upon cs upon 1 upon cs, 1 upon cs plus r. So it will be 1 upon 1 plus src. So how much gain is there? Again the gain is 1 upon 1 plus src, which is equivalent to 1 by under root 2. So again you are getting 1 by under root 2 gain. So 1 by under root 2, 1 by under root 2, 1 by under root 2. So 3 times you are multiplying. So this much gain you are getting. Okay, so this is the total gain that you are getting from this closed loop. From the closed loop, this is the total gain. First stage GMRD, then GMRD upon 1 plus GMRS, then 1 upon 1 plus SRC, again 1 upon 1 plus SRC, 1 upon 1 plus SRC, 1 upon 1 plus SRC. So 1 upon 1 plus j omega RC. So you are getting 1 by under root 2 to the power 4. So this is the total gain you are getting. GMRD whole square 1 plus GMRS 1 by under root 2 to the power 4, and this gain should be equals to 1. So what you are getting? This will become 2 to the power 2. So what is the value of GM? GM is 1 millisiemens into RD whole square upon 1 plus GMRS. What is the value of RS? RS value is 3. So this will become 1 plus 3. And this will become 4. That is equivalent to 1. So 1 millisiemens into RD. This will become 4 into 4, 16. 16 under root if you take, this will become 4 only. So what is the value of RD you are getting? 4 kilo. Okay, in a rough way we are solving, but calculation and all you can do. My target was to tell you the concept. Concept was GMRD from GMRD upon 1 plus GMRS, from here to here 1 minus 1 upon 1 plus SRC, then from here to here 1 upon 1 plus SRC, 1 upon 1 plus SRC, 1 upon 1 plus SRC. This is also my own creation only. This question, this whole circuitry, everything is made by me only. Okay, so yeah. So here as well you can see that phase shift also we can find out 1 radian per second, and this is the RD value we can find out, which is 4 kilo. It was not a very difficult question if your concepts are fine. This should have been solved if your concepts are good enough. Okay, 180, 180, this will be 0, from here 180 and another 180 you need. So basically another 180 you need, that you will get from minus 4 tan inverse omega RC. So omega RC should be equals to 1. Omega value we will get. After that we need to comment on the RD value. So first stage gain GMRD, then next stage GMRD upon 1 plus GMRS, then 1 upon 1 plus SRC, multiply with 4 times, so that will be 1 by under root 2 to the power 4. That should be equated to 1. That's it. Put the values, get the answer. Okay, let's go to the next.
So let's solve this particular question. In the given circuit, both the diodes have forward voltage drop of 1 volt. Okay, and the switches is idle. The switch is idle. The switch is closed at t equal to 0. Determine the voltage across the capacitor at t equals to 1 second. What is the voltage across this capacitor at t equals to 1 second? Actually, the polarity also should be shown. Otherwise, how will you calculate the voltage, right? So my bad, I should have shown the polarity here as well. I will, in the question, polarity would be shown, right? VC, like this. So this is the polarity. So let us copy this question. Let us try to solve it, right? So let us first of all see what is happening before closing the switch in the past. So any transient question, always we have to solve in the past, right? So if I just see before t equal to 0, because before t equal to 0, obviously the switch will be open, because switch is closed at t equal to 0. Of course, before it will be open, right? So if it is opened, what is the scenario here? So this 2 ampere current source will sell. I have to flow 2 amperes. So 2 amperes would come here. It has only one direction, right? So this is open circuit, no current will flow. All of the current will be flowing through this diode. So this diode has to turn on. For this diode to turn on, this diode needs 1 volt, right? Because the forward voltage drop is 1 volt. So for this diode to turn on, it needs 1 volt. So it needs 1 volt. So who will generate that? This current source will generate that 1 volt, so that this diode is turned on, and so current flows through it. So before t equal to 0, this diode, let's say this diode is D1, this diode D1 is on, and it has a volt. It will obviously provide a forward voltage drop of 1 volt. That is for certain, right? And 2 amperes current will flow through this diode. So ID1 of 0 minus is 2 amperes, right? Forward bias current. What about this side? This side is interesting, right? Because this 1 ampere current has two paths. One path is here, another path is here. Now let's assume at t equals to minus infinity, this capacitor had no charge. If this capacitor had no charge, so this will try to behave as short circuit. Now tell me, where will this 1 ampere current flow? Obviously, to turn on this diode, I need 1 volt, right? 1 volt, but this is already short circuit. So this diode will be off because this is 0 volt. So what will happen? The whole current will flow through this capacitor. And whenever a constant current flows through a capacitor, what happens? My capacitor voltage linearly rises in whatever direction, right? So right now the current is going like this. So if I measure my voltage like this, the capacitor voltage in this direction will increase linearly. What will be the slope of that? All these I have taught in my transient course, right? All this I have taught in my transient course. The slope will be IC upon T. IC upon C, right? That will be a slope. The capacitor current, that is 1, the capacitance, that is 1, slope is 1. So the voltage, right, Vc of t will be minus t. Why minus? Because I have assumed my polarity direction to be this, but actually the voltage is increasing in the opposite direction. So that's why I have added a negative sign. That's it. So minus t, right? Minus t. It is increasing in this direction linearly. So this voltage, it will increase, it will go to minus 0.1, right? Like this in this direction, then 0.2, then 0.3, then 0.8. It will keep on increasing. Till that point, this diode has 0.8 volt, right? Still this diode will not be turned on. the moment I reach 1 volt, moment this capacitor voltage goes to 1 volt. I'm talking about past, right? I'm still at the past. I'm not talking about the future. I'm talking about t less than 0. So the moment I reach 1 volt, what will happen? This will reach 1 volt. This is the current source. Then the diode will be turned on suddenly. Why? Because I have applied 1 volt, right? So that is just enough for the diode to turn on. So as soon as this diode will receive the 1 volt, then what will happen? Then this diode will not go beyond 1 volt, right? Because the forward voltage is 1 volt. If that voltage is, let's say, 1.1 volt, if the voltage is 1.1 volt, what will happen? For the voltage to be 1.1 volt, this diode needs to be turned off. If this diode is on, because this diode will turn on, right? After, if I'm applying 1 volt here, then if I'm applying, so let's say I have a diode here, right? And I'm applying, the cut-in voltage is 1 volt. I'm applying 1.1 volt. What will happen? This diode will simply turn on, right? This diode will simply turn on. And what will happen to that 1.1 volt? What will happen to the 0.1 volt? That will be discussed in analog electronics lectures. I will not discuss here, right? There is a concept that will be discussed in analog electronics lecture, not here. So the moment it reaches 1 volt, this diode will be turned on, and whatever the current was flowing through this capacitor, all of the current will be flowing through this diode. Why? Because this will reach steady state. The voltage will not change anymore because the diode voltage has been fixed. The forward voltage drop 1 volt. So the voltage will not change. So C dVc dt is equals to 0. So current through this will be 0. So all of the 1 ampere current will flow through the diode. So technically, the ID2 0 minus is also 1 ampere. This diode is also on. But just one difference, that the voltage across this diode is 1 volt, and the capacitor Vc of 0 minus is minus 1 volt because it is obviously opposite direction. I have assumed my voltage polarity to be this. So it is opposite direction. That's why the voltage will be Vc of 0 minus will be minus 1 volts, right? Now, what I am asking after closing the switch t equal to 0, the voltage across the capacitor at t equals to 1 second. So let us close the switch. So what is the scenario right now? The scenario is only one memory element is there, right? Only the capacitor. So I have to care about the capacitor. So this is short circuited and this has voltage in this polarity of 1 volt, right? This diode is on, that's fine, but diode can change its state instantaneously. There is no memory with diodes, right? So again, let's reconsider it. Again, let's see what is happening. Again, I have 1 ampere current coming from here and here, right? Now, as this switch is shorted, so all of these elements are in parallel, and we know capacitor does not want to change its voltage instantaneously, right? So it will try to keep the same voltage. So I have 1 volt across these two nodes. So if I have 1 volt, right, in this direction, and this diode requires what? Diode requires 1 volt for it to turn on, but in this direction, right? in this direction, but I have 1 volt in this direction due to this capacitor. So this diode will be off. So the moment this diode is turned off, that means this 2 ampere current is coming here. This will not flow through this diode. This will come to this switch, right? This will come here. Okay. And I have this 1 volt, and we know this diode is already on. This diode is already on, right? Because I have 1 volt, right? This diode is on. I can replace this diode with its cut-in voltage, right? But for a diode to be turned on, the current can never flow from N to P. It has to flow from P to N. So this 2 ampere current, obviously, it cannot flow through this diode because it has to flow through P to N, right? This 2 ampere current will only come here, okay? Because it cannot flow from N to P, it has to flow from P to N. So 2 ampere current comes here, 1 ampere current is outgoing. So remaining 1 ampere would come here. Now something interesting is happening. The capacitor right now is charging, but in other direction. In this direction it is charging, right? Because current is entering here. So this 1 volt, right, or minus 1 volt for VC will go towards 0, and then it will be more positive. Why? Because it is charging towards the other direction. So if you don't understand all this, you have to go and watch the transient videos of my lectures, right? Network theory. There I've explained all these things. So it is charging in the other direction. Again, the current here is constant. What will happen? The moment this 1 ampere current is flowing, the voltage will, because it is charging in other direction, let's say the voltage goes to 0.99 volts, right? It will reduce because it is charging in other direction. The moment I reach 0.99, this diode will be off. Because I need minimum of 1 volt for this diode to be turned on in this direction. But the voltage is reducing and it will reduce further. So this diode will never be turned. This diode will never be turned on. So all of this 1 ampere current is flowing through here, and this will always flow. This 1 ampere current will flow from here, come back here, go here, come here, and again. So 1 ampere current is coming here, another 1 ampere is coming here. So from here 2 ampere current will come, and this 2 ampere current will again return back to the current source. So again the capacitor is linearly charging, but in the other direction. What is the equation? Again IC upon T, IC upon C, right? IC is again 1, but in the other direction. Remember, in the other direction, 1 upon 1, that is 1. And obviously the equation of the capacitor voltage, this time this equation was for t less than 0, actually, to be honest. Basically not t less than 0 specifically, this was for the initial part when the capacitor was around t equals to minus infinity, because obviously after it reaches minus 1 volt, then nothing changes, right? Everything will be same. And now this equation plus t is valid for t greater than 0 only, right? Okay, this is the capacitor voltage. What are they asking? They are asking me the value of the capacitor voltage at t equals to 1 second. Just one thing we have missed here, right? If I say that, okay, I will put t equals to 1, this will be 1 volt, then you will be wrong. Why so? Because we have to also consider that the initial condition, right? The voltage across the capacitor initially was minus 1. This is minus 1, right? If you remember, this was minus 1. According to my reference polarity, this is minus 1. So the proper equation would be t minus 1. Okay. How to write this equation? Again, you have to watch the full course. I will not be able to explain over here. So this will be t minus 1. So my actual answer would be at t equals to 1 second, this will be 1 minus 1, that is 0 volt. So you actually don't need polarity here, right? But still, for the question to be proper, we need to provide polarity. So answer would be 0. 0 volt would be an answer for this particular question. A silicon diode of V gamma 0.7 volts and the thermal voltage as 25 millivolts is connected in series with a resistance R and a source, this, right? So basically I have a V of t that is connected. I have a diode, right, that is in series with a resistor, basically, right, of 1k resistance. Now this is my input voltage, and they are just simply asking me the peak to peak variation in the diode current over one cycle. So my input is sinusoidal. So what we can do, because my current will also be something sinusoidal, we can apply the small signal model of this diode. If I see that the DC value of the voltage is 2, so if the DC value of the voltage is 2, that basically means I have 2 volt over here. And initially if I assume the diode to be off, right, open circuit test, if I assume the diode to be off, so this, if I assume this to be ground, so this point potential would be 0 volts, right? So of course, if I take the bias condition, the diode is turned on, right? Diode is turned on. So the diode is on. So I can simply replace the diode with its small signal resistance RD, right? and I can replace this. So I can replace this with, so Vt will be combination of the DC value plus the AC value, right? So I just have to calculate the peak to peak variation, because the current also will be, current will have a DC component, and it will vary about a DC value. So I have to just compute this peak to peak variation, right? Okay, I have to compute the peak to peak variation. So if I have to compute the peak to peak variation, so I can just calculate the AC current, and I already have a resistance here, 1 kilo ohm. I have to just compute this AC resistance, and I know the AC voltage, that is 3, right? 3 sine t, and I can simply calculate the AC current, and I can get the peak to peak value, right? So first of all, yeah, diode is on, so I have to calculate RD. RD is what? If you remember, RD was basically my thermal voltage Vt upon I dq, the diode quotient current, the DC current basically. What will be IDQ? IDQ will be the current due to the DC voltage, right? So if there is DC voltage, that is 2 volt, the diode will be on, and we know the V gamma of the diode is 0.7, so diode will be replaced with 0.7 volts. So the voltage across this resistor will be 2 volt is the DC voltage, and 0.7 is gone, so 1.3, right? So basically it will be 2 minus 0.7 divided by R, 1 kilo ohm, that is essentially equals to 1.3 milliamperes. Okay, 1.3 milliamperes, right? So this is 1.3 milliamperes. Now okay, so the quotient current is 1.3. I know the thermal voltage, that is 25 millivolts. So 25 millivolts upon 1.3 milliamperes, this will be equals to, let me calculate this, 25 divided by 1.3, that is 19.23 ohms. So the small signal resistance is 19.23 ohms. So I can replace in this circuit 19.23 ohms. So my overall current, right, would be equals to the small signal AC current would be equals to 3 sine omega t divided by the overall resistance, because this is the voltage, right? So 1 kilo ohm, that is 1000 plus 19.23. So this will be equals to 1000 into 3. So this will be approximately 2.94 sine omega t milliamperes, and you will mark 2.94 and you will be wrong, because they have asked you the peak to peak variation. So this is just the peak value, not the peak to peak. Peak to peak will be 2 of Im, right? Twice of this. So if I multiply 2, so I peak to peak would be 5.89 approximately, or 88 approximately, right? 5.88 or 89, whatever you would say, approximately milliamperes, and you will mark this answer, and this also will be wrong. Whatever we have done here, everything is wrong. Everything is wrong. Why? The moment I told you that we can use the small signal model, we did not ensure that my voltage, the AC component of the voltage, is small enough. It may happen that my diode may move out of my turn on region. How? If you observe here, right, that let's say at t equals to, whenever this sine omega t, what is the minimum value of the sine omega t? Minimum value of sine omega t is -1. So this will be what? This will be 2 minus 3, that is -1. So I have a -1 voltage here. That will take this diode out of the on region to off, right? So diode, the region of operation is changing. The moment when we said that we can replace my diode with small signal resistance, we should have also checked the amplitude, right? Compare the amplitude from the DC value to the AC value. The AC value should be very small compared to the DC value. That's why it is called as small signal model. The AC component should be small. Then only we can do the linear approximation. So this is what I will obviously teach in the diode circuits lecture in our analog electronics lecture in the Hindi channel, right? All these things I will teach. So how do I then calculate peak to peak variation? It's very simple. Calculate the maximum value of current. What will be the maximum value of current? Whenever the voltage will be maximum, then the current will be maximum. What is the maximum value of this? Sin omega t maximum can be 1, right? So Vmax will be equals to 5. So Imax, maximum value of current, will be equals to 5 minus 0.3, because diode obviously will turn on, divided by 1 kilo ohm, not any small signal resistance, right? Small signal was just replaced due to this assumption, but that is wrong. So that will be simply replaced with a 0.7 volt cut-in voltage. So this will be 4.3 milliamperes. That is a maximum value. What is the minimum value of the current? Current can never be negative, right? Through a diode, the current can never be negative. So the current will be minimum 0, because the diode will be turned off. So minimum value of current, I mean, is 0. So what is the peak to peak variation? What is the peak to peak? It will be simply Imax minus, not this is I mean, right? Imax minus I mean, which is 4.3 minus 0, that is 4.3 milliamperes. So your correct answer is actually option C. This is your correct answer. So I just took this question just to clear the misconception that you can just blindly apply the small signal model. No, you have to confirm that your actual source, the small signal part or the EC part, is much smaller compared to your DC part. Then only we can apply this small signal model. Otherwise you cannot apply, because it will not be simple linear. We cannot do it. There are certain restrictions. That is what I will teach in my Hindi lectures. So yeah, 4.3 milliamperes, that is option C would be the correct answer for this question. In complex function f of xy, uxy plus I vxy, where I is the imaginary part and x, y, u and v are all real. These are all real values except I, and f of xy is basically analytic. Then which of the following equations is / are true? Okay. So do you remember something? When f of xy is analytic, what is the relation? So basically, if I differentiate the real part with respect to x, that will be equals to the differentiation of the imaginary part with respect to y. That is the condition for analyticity, right? And another condition was, if I differentiate the real part with respect to y, then the imaginary part with respect to x will be just the negative. These were called as Cauchy-Riemann equations, right? They has to satisfy the Cauchy-Riemann equations, but I don't see those here. What do I see is something else. And these also I have taught in my full course, that they must be the double derivative addition also must be 0, but we can prove it from directly here, right? So if I differentiate this equation 1 with respect to x, again this will be del square u by del x square. This will be equals to, if I differentiate this one, right, this will be del square v by del x del y. And if I differentiate this one with respect to y, this will be del square u by del y square equals to minus del square v divided by del y del x. Now there is something interesting. Whenever a function is analytic, that basically means my u and x are continuous. And if u and x are continuous, then there is another relation, that del square v del x del y will be equals to del square v del y del x. These two must be equal if the function is continuous everywhere. That means these two values are equal. That basically means that if I add these two, right, if I add, let's say, equation 3 and equation 4. So if I add equation 3 and equation 4, this will be basically del square u divided by del x square plus del square u by del y square, and the right hand side will be simply 0, because these and these are same. So plus minus 0 only, same values but negative, so 0. So this will be equals to 0. So the addition of del square u by del x square plus del square u by del y square will be equals to 0. So first option is certainly true. right? What about the second option? Second option will be true, right? If you again do the other thing, right, what do you do in this equation? If you differentiate with respect to y on both sides, here also you differentiate with respect to x on both sides, you will get the same result, exact same result. You will add those two and you will land to this particular conclusion, right? But this conclusion you will not be able to land to, right? This is not true. Del square u plus del x square will not be equals to del square u. Sorry, this addition will not be equals to 0. You will not be able to land to this conclusion, right? Okay. These are called basically the Laplace equations, Laplacian equations, if you remember. This I have taught in my full course, right? What about this part? So this, right, is basically the multiplication of del u del x into del v del x. So del u del x into del v del x. So basically, if I multiply 1 and 2, right, this is two equation. If I multiply 1 and 2, what do I get? So I can multiply these two things, right, together. This will become del u del x into minus of del v del x. Simply multiplying the two equations, that's it. And this will be equals to, so I multiplied these two parts together, so I have to multiply the other two parts as well, then only they will be equal. This will be equals to del u del y into sorry about that, into del v del y, right? So I can take this on the right hand side and I will get back the same equation, right? So option A, option B and option D, all these three are correct. Let y of x be solution of the differential equation, and the initial conditions of this, then determine the value of 100 y of y of e, right? That is what we have to determine. So it's pretty simple. This is simply in the form of Cauchy's differential equation, right? Cauchy. If you remember what substitution we used to make, x equals to e raised to power z, right? If you remember, like, this is the standard form of Cauchy's differential equation. We used to make this substitution, x equal to e raised to power z, and we used to say that x square into d square y upon dx square would be equals to d, basically this will be equals to d of y, hold on a second, not this. So basically we used to replace x dy dx as dy dz, and we used to write this in the format of dz, right? Like, I am not teaching you the exact method, this I have taught in the mathematics course. I'm just showing you the solution here. So this x square d square y by dx square will be replaced with dz into dz minus 1, and x dy dx would be replaced with dz. And we can write this equation in terms of z, and from there we can solve, we can get the complementary function, we can get the particular integral, and then we can back substitute, right? So let us first calculate the complementary function. So complementary function, let me replace this differential equation. X square dy square by dx square would be replaced with dz into dz minus 1 plus 7x into dy dx, that will be replaced with 7 dz plus 9, okay, equals to 0. I'm just calculating the complementary function for now, right? YCF. In terms of z right now, in terms of z, I'll replace z in terms of x here. So what is z in terms of x? That will be equals to ln of x. So this will be basically dz square plus 6dz plus 9 equal to 0. So this is again, what are the roots of this auxiliary equation? Dz plus 3 whole square equal to 0. So basically I have real and repeated roots. So for this, we know YCF comes out to be c1 plus c2 x. No, this will not be x, this will be z, because the differential equation is in terms of z, not x. E raised to power minus the root. What is the root? Minus 3, right? So this will be minus 3z. Okay, this is the complementary function. And if I want to find out the values of the complementary function, I can directly put the values over here, right? So basically I know y of 1 is 0. So if I put y equals to 1, so what is 1? What is this 1? This 1 basically means x equal to 1. But here I have written y in terms of z. So when x is 1, what is z? Z is equals to ln of 1, that is equals to 0. So when x is 1, z is 0, right? So we have to replace z equal to 0. This will be c1, z is 0, so this will be 0 only. and this will be e raised to power minus 0, that is 1, right? Equals to what? Equals to 0 only, right? So this will be y of CF is 0 at that point of time. So my C1 comes out to be 0. What about C2? So for C2 I can use the second condition. So I have to differentiate this equation on both sides. So if I differentiate this, what will I get? This will be C1. So if I differentiate this, sorry, this will be first, this is chain rule, so this differentiation will be 0. Anyway, C1 is 0 only. So ultimately my equation comes out to be this, right? C2z e raised to power minus 3z. So C2 is just a constant. If I differentiate this, this will be e raised to power minus 3z minus 3z e raised to power minus 3z, right? So this is my derivative of CF, and then I can again put the initial condition that when x is 1, z is 0. So let's replace z equal to 0. So if I replace z equal to 0, this will be simply e raised to power 0, that is 1 minus 0, and this is equals to also 0. So your C2 also comes out to be 0 only. Okay, so your complementary function is simply 0. Your complementary function is simply 0. So you don't have a complementary function, unfortunately. So we have to calculate the PI. How do I calculate the PI? So for calculating PI, what do you have to do? So let's replace this x in terms of z. So I know my x is equals to e raised to power z. So this x raised to the power minus 3 can be replaced with e raised to power minus 3z. ln x is nothing but z, right? Z is ln x. So this will be simply z. So for calculating PI, if you remember, what you should do, we should divide the auxiliary equation, right, by the right hand side, whatever is there in the right hand side. In the right hand side, I have e raised to power 3z, e raised to power minus 3z z divided by dz minus, sorry, plus 3 whole square, right? Okay, now how we used to solve this? If you remember, whenever I had in this format e raised to power ax some f of d, right? How we used to solve? We used to get this e raised to power ax outside this differential, like whatever this integral, and we should replace my f of d with d plus a, right? That is what we'll do. If you remember the format, this is how we solve particular integral, right? This is just the format. So my a is minus 3, so I'll bring this e raised to power minus 3z. Just hold on a second, someone is calling me. E raised to power minus 3z outside, and this z will be dz plus 3, and of course I have to replace with dz plus 3 is already there. I have to replace d plus a. So a is how much? Minus 3 plus minus 3, right? Whole square. So I have to replace d with d plus a. So d plus 3 will be replaced with d plus 3 minus 3. So this will be simply a raised to power minus 3z z upon dz whole square, right? And what is dz whole square? It is nothing but integrating z twice. That's it. So 1 by d is nothing but 1 by d is what? Inverse of derivative. D is derivative, right? That is d dx. In 1 by d means inverse integration. That's it. But integrate in terms of z, because this is in terms of z. So I'll have to first, so this I can write as e raised to power minus 3z z upon dz into dz. So I will integrate twice basically. So once if I integrate, integration of z is simply z square by 2, right? And again if I integrate, this will be z cube by 3, and 2 is already there, so z cube by 6. So this is my ypi in terms of z. But what do they have asked? They have asked me the value of 100 ye. When x is e, what is my z? So ln of e is 1, so z will be 1. So I have to simply put z equals to 1 in this equation, because my overall y function is simply ypi plus ycf, but my cf is 0. So it will be simply e raised to power minus 3z z cube by 6. I have to replace z with 1 here. ln of e is 1. So this will be e raised to power minus 3, 1 divided by 6. But this is not my answer. My final answer is 100 times this. So let me write down of my final answer. My final answer would be 100 e raised to power minus 3 divided by 6. So hold on a second. E raised to power minus 3, right? into 100 divided by 6. So this approximately comes out to be 0.83. So 0.83 would be your final answer of this particular question.
Yeah, hi everyone. So we will solve this question, but before that, I will ask you. This is actually a very interesting question. But before that, let me ask you a question. That let's just say this is our capacitor C, and then I am having another capacitor C, and this is having initial voltage of 1.25 volt. Here I am applying 2.5 voltage. So now I am asking you, just as I close the switch, what will be the steady state value of V naught? What will be the answer? Will you simply divide the voltage 1.25, 1.25? No, what you will say? Sir, it will be, I hope you know this method. So what will be the voltage? Sir, 1.25 is initial. Then see the whole voltage in the circuit, that is 2.5 minus 1.25. So it will become 1.25 here, and then divide it between both of the capacitors. So what will be your answer? Your answer will be 0.625. So answer will be 1.875. This will be your answer, right? At the steady state. 1.875, and here what will be the voltage? This will be like at the steady state, the circuit will look somewhat like this. 1.875, and here you will get 0.625. Here you will get 0.625, and this will be your 2.5. This will be the scenario at the steady state, right? This will be the scenario. I hope you know it. How this formula came, that we have studied in the comprehensive course. By simply, like, you will say that delta V will be provided, like if this capacitor is getting delta V, like both of the capacitors will be having same current, no? So if you are getting delta V charge here, then how much charge you will get? Here also you will get extra delta V charge. So if you get extra delta V charge, then what you can do? 2.5 could be equated to 2 delta V plus 1.25. So what is the value of delta V you are getting? Delta V value, because both of them are having the same current, no? Both of them are having the same current, that means both of them should get the same charge, that is C delta V, right? This is having the same capacitance, so this is getting C delta V charge, then this will also get C delta V charge only. So both should get the same charge. So here 1.25 plus delta V, here also delta V. So from here the value of delta V is coming out to be 0.625. So at the steady state, this will have the voltage of 1.25 plus 0.625, and this will have the voltage of 0.625 only. Okay, so this will be your answer. In this question, this will be your answer. Understandable? Now another question, if I am asking you, this circuit also we have seen in the class. If you have studied through the Laplace transform, then I cannot do anything. Okay, this is the real beauty of network analysis, not Laplace transform and all. The actual charge conservation and all these things are discussing. All these things we are discussing. So let's just say this is charged to 2.5 volt, and this switch I am closing at t equals to 0. So what will be the steady state voltage on both of the capacitors? So that will be nothing but 2.5 into C would be equals to 2C into Vx. So value of Vx will come out to be 2.5 by 2. So both of them will have 2.5 by 2 and 2.5 by 2 at the steady state. So what really has happened, that from here some delta V charge went out, and this has developed some delta V charge. Like initially what really happened, the whole voltage was developed across the resistor. So what really happened was, this was driving some current. This was having, oh sorry guys, sorry. This was the resistor in series. Sorry guys, steady state, this is the scenario. So initially what was the scenario? This is having 2.5 volt, this is having 0 volt. So 2.5 by R current was flowing. Now slowly the current started flowing. So this capacitor started charging, and this capacitor will start discharging. So this will start losing delta V, this will start gaining delta V. What will happen at the steady state? At the steady state, sir, the current through the capacitor should be 0. Current through both of the capacitors should be 0. That means current through the resistor should be also 0. So if the current through the resistor is 0, that means both of them will have the same potential, because here there is 0 current. That means both of them need to have the same potential. So this guy has lost delta V, and this guy has gained delta V. That means what will be the value of delta V? So from here the value of delta V is coming out to be 1.25. So this has gained 1.25 voltage, and this has lost 1.25 voltage. So this will come at 1.25 voltage. So these examples we have seen. Understandable? Let's solve this question. What I will do, first of all, can you see that you can get the equivalent from here? You can get the Thevenin equivalent of this side. So I will get the Thevenin equivalent of this side. I can directly see that, sir, resistance will come out to be R by 2. Resistance will come out to be R by 2. And the voltage Vin will become Vin by 2. So that will come out to be 5 by 2 ut. This will be the voltage that I will be having. Now I am having two capacitors, C1 and C2. C1 and C2. Okay, and this is your V0 voltage. What is given, sir? Initial voltage across C2 is 1.25 volt. Now, sir, what will be the voltage at the steady state? This is what they are asking. Find the steady state value of V0 T. This is what they are asking. So, sir, at the steady state capacitor will be open circuited. So, if you are thinking that, sir, complete 2.5 volt will come here, that means you are very much lagging in the concept. If you are thinking that, sir, at the steady state, sir, this will be the circuit R by 2, and then, sir, everything will be open circuited. So, what will happen? What will happen is that, sir, complete 2.5 volt that was applied here, that will come here. So, answer will be 2.5 volt. If this is your answer, that answer will be 2.5 volt, then that is absolutely baseless. You lag in your concept. I am really sorry to say that. Secondly, if your concepts are decent enough, then what you will be thinking that, sir, both capacitor will come into action. No, although they are open circuited, but they are available here. No, this is your C1 that is available. C2 is also available. Both are equal to C only. So how the voltage will be divided? So 2.5 volt will come here. There is no doubt because the resistor is driving 0 ampere current. So 2.5 volt will come here, and that will be divided into both of them. 2.5 volt will be divided into both of them. So the voltage will become here 1.25, here 1.25, and here also 1.25. So what you might be thinking is that, sir, initially capacitor was having already 1.25, steady state as well it is having 1.25 only. That means the charge of capacitor did not change. Is it a first order circuit? Yes, it is a first order circuit. So it cannot happen that it was at 1.25, then it went up, then again it came down. It cannot happen because it is a first order circuit. So it will have an exponential response, or it will have directly a steady state response. So from this answer it feels like that, sir, C2 is not changing its charge at all. It will be always at 1.25 only. Initially you gave 1.25, at the steady state as well, sir, I am getting 1.25 only, because here what I will get 2.5. Then here what I will see, here I am getting 2.5. So what I can see is that 1.25 to this, 1.25 to this. So it is never changing its voltage. This is the VC2 voltage or V0 voltage waveform that I am getting. Is it correct? Let's check the circuit at t equals to 0 plus. At t equals to 0 plus, what is the scenario? At t equals to 0 plus, here there is 2.5 volt. Here there is 2.5 volt. Now this is charged to 1.25 and this is having 0 volt initially. I am talking about t equals to 0 plus. This is having 1.25 and this is having 0. So what will be the potential here? That will be 1.25 volt. So 2.5 volt here, 1.25 volt here. That means resistor will drive some current. That will be 1.25 R by 2. So resistor is driving 2.5 by R current. So let's take R equals to 1. So resistor is driving 2.5 ampere current. Now the same current will be flowing through this capacitor as well, and it will be flowing through this capacitor as well. That means both of the capacitor has to charge. Here you assumed in this manner, as per you, sir, capacitor C2 is always at the steady state. This is the waveform that you have drawn. If I analyze the circuit at t equals to 0 plus, what do I see? 1.25 here, 0 volt here, 1.25 will come here. So 2.5 minus 1.25, resistor is driving some current. If resistor is driving some current, then surely the same current will be flowing through C1, and surely the same current is flowing through C2 as well. That means C1 will develop some voltage, then C2 will also have to develop some voltage. No. At the steady state, if you are saying that C1 has developed some voltage, that means some current would have flown. And if some current would have flown from C1, then the same current would have flown from C2 as well. Say yes or no. Are you able to understand this point or not? What I am saying? The same current would have flown from C2 as well. That means C2 is actually changing its voltage. So C2 will rise above to 1.25. So this answer that you have got, that is wrong. So something you are missing out here. That's the beauty of this question. Are you able to understand this point? A lot of people would have marked the answer as 1.25. If I did not even give the option of 2.5 volt, that is fine. But a lot of people would have marked the answer as 1.25 volt. I am telling you, I know that. But that is wrong. You thought that it is a steady state, but it is actually not the steady state, because both of the capacitor will drive the same amount of current. So the point here is that if this capacitor is, because both of the capacitor will have the same current always, no? So if this capacitor is developing delta V voltage, then this capacitor will also develop delta V voltage only, no? This is the scenario that there is a resistor, sir. There is a capacitor, there is another capacitor. This is your capacitor C only, and this is your capacitor C. Both are having the same current. If this is developing delta V, initially it was having 1.25. So sir, this will also develop delta V only. Both will develop delta V. And here how much is applied? 2.5 volt is applied. At the steady state, what will happen? they will not drive any current, they will not drive any current. That means current through this resistor will be 0 ampere. So drop here will be 0. So at the steady state, what you can say, 2.5 would be equals to delta V plus 1.25 plus delta V. So what answer you are getting? So delta V would be nothing but 1.25 divided by 2, so that would be 0.625. So delta V is coming out to be 0.625. So at the steady state, the capacitor will have the voltage equals to 1.25 plus 0.625. That would be nothing but 1.875. Did you understand this question or not? Again, with the patience, you understand that sir, C1, C2 both are in series. They will drive the same amount of current. That means they will develop the, since they are having the same capacitance value as well, that means they will develop the same voltage. If C1 is developing delta V voltage, then C2 will also develop delta V voltage only. At the steady state, sir, what is the meaning of steady state in the capacitors? The meaning of steady state in the capacitor is that they should not be driving any current. If you give any current to the capacitor, then its voltage will rise up. If you give any voltage to the inductor, then its current will rise up. That's the common knowledge that we have. That means current through the capacitor should be 0. When we say that at the steady state capacitors are open circuited, what do we mean? That current through the capacitor is 0. So current through the capacitor should be 0. That means the current through the resistor also has to be 0. So what does that mean? 2.5 would be equal to delta V plus 1.25 delta V at the steady state. So delta V is coming out to 0.625. That means this capacitor at the steady state will have 1.875 voltage. At the steady state, it will have 1.875 and this will have 0.625. So 0.625 plus 1.875 will be equal to 1.25. So it will be equal to 2.5. Is that understandable to you or not? So this was a very good question. The answer is 1.875. This is the actual answer. Is that understandable or not? Okay, a very good question. I hope you are able to understand. Let's go to the next question. Yeah. So order of the circuit. One way would be that you solve it through the Laplace transform. You can solve it very easily through the Laplace transform. Other one would be that go by the intuition. So you can solve it by Laplace transform on your own. I will tell you the intuitions. Okay. So with respect to that transfer function of V naught S by V in S, what will be the order of the circuit? That we need to find out. So V in S is the known voltage. If I give a unknown voltage to L2, then can I write down the voltage across L1 in terms of the known voltage? Yes. Now V in T is also known, V naught T is also known. So voltage across L1 will be V in T minus V naught T. So yes, I can write down the voltage across L1 in terms of known voltage. What does that mean? That means here this will be the first order transfer function. So transfer function will come out to be, the order of the circuit will be 1, considering V naught T as the output and V in T as the input. V naught T as the output and V in T as the input. The order is first. So how the transfer function would look like? AS plus 1. But you cannot comment anything about 0, right? As of now, you are not commenting anything about 0. You know that, sir, there will be one pole that will be at minus 1 by A. I don't know the value of 1 by A. I don't care. I only know that there will be a pole at minus 1 by A. What about the 0? Sir, 0 I don't know. I don't care about it as well. But I only care about the 0 at omega equals to 0. Like, is there any 0 at omega equals to 0? If you put omega equals to 0 in this particular circuitry, at omega equals to 0, inductor will be shorted, the whole circuit is shorted. What does that mean? That means the potential will be actually divided between both of them. This will drive 0. If a whole circuit is shorted, then what will happen is that this will drive 0 ampere current. If you are saying a whole circuit is shorted, so at omega equals to 0, whole circuit is shorted. Like, it is not possible. No, this is V in T and whole circuit being shorted. It is not possible. What does that mean? The potential will be divided between these two. So here, how much potential you will get? Here the potential that I will be getting is L1 upon L1 plus L2 into V in T, whatever it is, and here I will be getting L2 upon L2 plus L1. So my gain at S equals to 0 will come out to be L2 upon L2 plus L1. That will come out to be 3 by 5. So the gain will come out to be 3 by 5. So the transfer function will look somewhat like this. V naught S by V in S, 3 by 5 AS plus 3 by 5 AS plus 1. This is how the transfer function will look like. Right? With respect to V naught S and V in S. Why I am caring about the 0 at omega equals to 0? Why I checked at omega equals to 0? Why I checked the DC gain? I checked the DC gain because now they are asking about I naught S by V in S. So one thing I know that, sir, I naught S could be written as V naught S into LS. So here what I can write down? V naught S could be written as I naught S into LS. Sorry guys. V naught S could be written as I naught S into LS. So in place of V naught S, what I can write down? I naught S into LS into L2S divided by V in S equals to some 3 by 5 divided by AS plus 5. So now from here what you can see, I naught S by V in S is coming out to be 1 by L2S. What is the value of L2? The value of L2 is 3. So it will come out to be 1 by 3S into 3 by 5 divided by AS plus 1. Now why I cared about the 0 at omega goes to 0? Why I cared about it? Because sir, if there was some S available, no, then this S and this S would get cancelled out. If I was having a 0 at omega goes to 0, then sir, in the numerator S would be available. It would be looking somewhat like this. In the numerator S would be available, and then sir, this S is coming, so this S and this S will get cancelled out. Are you able to understand this point? So that's why I checked the circuit at omega goes to 0. At omega goes to 0, am I getting the gain to be 0? I'm not getting the gain to be 0. That means this cannot be the transfer function. So this cannot be the transfer function. I am getting a DC gain equals to 3 by 5. So I am putting 3 by 5. So there is no S available here. There is no S available here. That means how your transfer function is looking like. Your transfer function I naught S by V in S is simply looking like this. That is 3 and 3 can get cancelled out. I don't care about it. Upper side there is 1 by 5 or whatever there is some DC value. There is some DC value A divided by S into AS plus 1. S into AS plus 1. This is how it is looking like. So it is having two poles, one pole at S equals to 0 and another pole at S equals to minus 1 by A. So how many poles it is having? Two poles. So is it a first order circuit? Absolutely not. It is a second order circuit. So this option is wrong. This option is correct. First of all, if you think that sir, order of the circuit is not defined with respect to output input, simply the question is what is the order of the circuit? Then this question is baseless. Order of the circuit is always defined with respect to output and input. If you are defining output as V naught S by V in S, then order would be different. If you are defining the output as I naught S by V in S, then the order would have been different. So if you simply say that sir, order of the circuit, because we have solved these kind of questions by good educators, right? There are a lot of good educators. We have studied from them. They are saying that what is the order of the circuit? That is absolutely baseless. You need to define the output, you need to define the input, then you will tell the order of the circuit. Understandable? So this is second order. With respect to this transfer function, it is first order. Okay. Steady state value of V naught T. What is the meaning of steady state in the capacitor? Sorry, what is the meaning of steady state in the resistor? The meaning of steady state in the resistor is that there should not be any voltage across the inductors. What is the meaning of a steady state in the inductor? Like let's just say there is some inductor. I am having some inductor. Now if I am giving it some voltage, then what will happen? If I am giving it some voltage, then surely sir it will drive some current. Surely it will drive some current. If I make this voltage 0, then it will not drive any further current, whatever the current was available. No, let's just say 3 ampere was available. So it will be settled at 3 ampere. Always 3 ampere will keep on flowing. But if you give it some voltage, then what will be the current? Current will be, or voltage, what is the expression? V equals to L di by dt. So from here I is Vt by L. I am treating voltage as constant. So if I am giving a constant voltage, then it will always keep on driving the current. With the time, the current will keep on increasing. So if you want the steady state in the inductor, what do you want? You want the voltage across the inductors to be 0. You want the voltage across the inductors to be 0. Then how my circuit will look like? I want the voltage across the inductors to be 0. This is my circuit. This is my resistor R. Then this is another inductor. Right? Input is V in T. L1, L2 and R. So you want the voltage to be 0. What is the meaning of 0 voltage? 0 voltage means short circuit. You want it to be short circuit. You want it to be short circuit. That means whole circuit is being shorted. Is it possible? Is it possible? Is this any kind of circuit is possible? No. So in this scenario, what is happening? This resistance is eventually the scenario is that the resistance provided by L2, like there is resistance R and there is some short circuit. That means sir, this particular wire is providing very lesser resistance than this one. So if I am giving you 1000 resistance and then 1 ohm resistance, 1000 resistance and 1 ohm resistance, what will be the equivalent of this? So the equivalent of this would be 1000 into 1 divided by 1001, which will be nearly equals to 1 only. So equivalent of this is nearly equals to 1 ohm only. So what will happen is that this parallel combination of RL could be replaced as only L2. At the steady state, sir, there is something wrong in the circuit. So what I am saying is that, sir, parallel combination, this is providing very less impedance. That means this will be replaced as L2 only. and this will be replaced as L1 only. So what will happen? This will be the scenario at the steady state. At the steady state, and what is the voltage here? Voltage is 5. So how the voltage will be divided? So voltage will be divided as L2 upon L2 plus L1 into 5. So L2 upon L1, L2 upon L2 plus L1, what that would be? 3 upon 3 plus 2, 5. That would be 3 by 5 into 3. 3 by 5 into 5. So answer will be 3 volt. So steady state voltage will be 3 volt here. 3 volt here. 3 volt. Okay. The steady state value of V naught T will be 3 volt. What will be the what they are asking? The value of current I naught T at 13.5 second. The value of current I naught T at 13.5 second. This is what they are asking. What will be the answer? At 13.5 second. Look, I know that it is a second order circuit, right? It is a second order circuit. I naught S by V in S is a second order circuit. It is a second order response that we are getting. Okay. And at the steady state, what I have seen, that this L2 is having a constant voltage of 3 volt. At the steady state, what I have observed is that L2 is having a constant voltage of 3 volt. This is your L2. Look, you can apply Laplace transform very easily and you can get the answer. But all my target is to give you the intuition. This L2 is having a constant voltage of 3 volt at the steady state. Always it will have 3 volt. If it is having always 3 volt, then what will happen? This L2 will always drive some current. No, because I told you, if your inductor is having a constant voltage, then surely it will drive the current as Vt by L2. So it will always keep on driving the current as 3t by L2. What is the value of L2? This will be the current, right? And what is the value of L2? Value of L2 is 3. That means it will always drive the current It equals to T only. It equals to T. So this current it will keep on driving. And they are asking at 13.5 second. That means at T equals to 13.5 second, what should be the current? 13.5 ampere. This should be the current. You thought this is the correct answer? Wrong. This is also wrong. Why it went wrong? Look, those are having very good intuitions. No, those who are studying in a good manner, then they would have clicked on this answer as well. I am pretty sure. Okay, this option was already wrong. Steady state value. This option was already wrong. But they would have clicked on this answer as well, thinking this as a MSQ, because this was given as a MSQ only. So they would have clicked on this answer as well, because they would be thinking that, sir, at the steady state I am having constant 3 voltage, so 3t by L. This is what they would have thought. You are going somewhere wrong. Where you are going wrong? And why I consider 13.5 second as steady state? Because, sir, if there is some transient part in the circuit, then, sir, the time constant would be, remove the input, the time constant would be L1 comes in parallel with L2. So L1 comes in parallel with L2 divided by R. So what that would be? L1 in 3 into 5, 1.2 divided by 2. So that would be 0.6 second. So whatever the transient part is there, no, sir, that will be dying down into 0.6 into 5. So the transient part will be dying down in 3 seconds only. That means, sir, 13.5 second is the steady state. Because, sir, transient part will die down in 3 seconds. So, sir, 13.5 is the steady state. Okay, so steady state is not a matter of concern, that, sir, why you took this as a steady state only. Why you said that, sir, L2 will be having 3 volt. At T equals to 13.5 second, L2 will be having 3 volt across it. That I can say with the guarantee. Why I can say with the guarantee? Because, sir, 13.5 is the steady state. Why it is a steady state? Because, sir, time constant is L1 parallel with L2 divided by R. Tau equals to L by R. So that is, sir, roughly around 0.6 second. And, sir, 0.6 into 5 in 3 seconds steady state would have been reached. So 13.5 very much higher time. So it is the steady state only. But, sir, still this answer is wrong. Why it is wrong? Because you did not notice one thing in the circuit. This is your circuit, no? And this is your resistor. So you are saying that I am having 3 volt here constant, right? At the steady state. The same 3 volt is here available as well. And what is the steady state voltage here? 2 volt you are saying. And total 5 volt was applied. Right? This is the scenario. This is your L1 and this is your L2. You are having 3 volt here. The 3 volt is here as well, no? And what is the resistance value? Resistance value is 2 ohm. That means So 3 volt is constant across L2. The same 3 volt is constant across resistor as well. That means resistor is also driving a constant current of 3 by 2 because the value of resistance is 2 ohm. So it is also driving a constant current of 3 by 2, which will be 1.5 ampere. So this resistor is also driving a constant current of 1.5 ampere. I know these questions are very deep. I surely know it. They are very deep question. But just think about it. It is driving a current of 1.5 ampere. This resistor is constantly driving a current of 1.5 ampere. Say yes or no. And let me know one thing. Across this resistor L2, is there any other element? No. L1 will say that I am alone. Across L1, is there any other element? No. L1 will say I am alone. And across me, there is 2 volt at the steady state. Across me, here you made this circuit, but you did one blunder. No. That's why there is 3 volt, but this is the circuit. This is how there is 3 volt available. Right? Are you able to understand this point? And it is not a battery of constant 3 volt. This 3 volt has come there. So similarly, this L1, what L1 will say? L1 will say that you can draw the circuit like this. That across me there is constant 2 volt. Always there is constant 2 volt. Across me there is always constant 2 volt and there is no other element. So what will be the current through L1? So the current through L1 will be Vt by L, Vt by L1, which will be 2T by L1, that will be T. So at 13.5, what will be the current? The current will be 13.5 milliampere. So through the L1, the current would be 13.5 milliampere at the steady state. There is no doubt about it. Now out of that 13.5 milliampere current, 1.5 milliampere current, this guy is eating up. So here what will be the current? Here the current will be 12 milliampere. Okay, milliampere or ampere, whatever it is. So here the current would be 12 ampere. This is ampere only. So across L1, sir, there was no resistance. There was nothing. Across L1, there was nothing. So across L1, there was 2 volt constant. If there is 2 constant voltage is available there, that means it will drive a constant current of 13.5 ampere at the steady state. Not the constant current. It will drive the, okay, this statement was very wrong. At the t equals to 13.5 ampere, at t equals to 13.5 second, it will drive the current of 13.5 ampere. Let me reframe the statement again. Let's start right from the beginning again. What I was saying. Across L1, there is no resistance, there is nothing. Across L1 at the steady state, like after 3 seconds, we know that voltage will be constant, which is 2 volt. If voltage is constant, which is 2 volt, then it will drive the current, which is equals to 2t by L2, 2t by L1. L1 value is 2, that means it will drive the current equals to t ampere. So at 13.5 ampere, you are asking which is after the steady state only. That means at the steady, which is after the steady state only. That means at 13.5 second, it should be driving 13.5 ampere current. At 13.5 second, this inductor L1 should be driving 13.5 ampere current. Now, sir, across L2, you are saying there is 3 volt constant. But sir, across L2, there is a resistor as well, which is driving 1.5 ampere current. From the other side, 3.5 ampere current is coming. 1.5 is going downward. So here, how much current would go? 12 ampere current would go. Say yes or no. So there was in the current L2, there was a DC part as well, which was 1.5. Okay. So answer will be 12 ampere. So solving these kind of intuition, getting these kind of intuition is nearly impossible in the examination hall. I know. But here I have given you the intuitions. In the examination hall, you could have applied the Laplace transform and you could have got the correct answer. Okay. And easier way would have been like you find out the voltage, then you find out the current. What I mean to say is that can you write down the voltage across the L2? Can you write down the equation of voltage across L2? What would have been the easier way for me? Voltage across L2. Can you first draw the waveform of voltage across L2? Sir, initially there was no voltage. Initially, sir, they will be open circuited because they are driving zero current. So initially they will be open circuited. So there was zero voltage, sir. Across L2, sir, there was zero voltage. Then what really happened, sir? The voltage went from 0 to 3 volt at the steady state, from 0 to 3 volt. This is the volt V0 T waveform. Can you write down the equation of V0 T? Yes, sir. It could be written as e to the power minus t ut. E to the power minus t by 2. E to the power minus t by 2 ut. E to the power minus t by 2, which is 0.6 only ut. This will be the equation of V0 T. Now what do I know? For the inductor, V equals to L dit by dt. So from here, it would become 1 by L VLT dot dt, from minus infinity to t. That means you are supposed to integrate this. With t greater than 0, this will become, what will be it? It will become 1 by L. Ut is already there, so you need to integrate from 0 to t. This is 3 into 1 minus a to the power minus t by 0.6. Ut will be gone dot dt. So you need to integrate this particular part. So you can see that first part would give me 1 by L2 whatever it is. First part would give me 3t. First part would give me 3 dot dt will be 3t. Now the second part is 3 e to the power minus t by 0.6 t dot dt. So what you will be getting? 3 e to the power minus 0.6. Here you multiply with 0.6, then you put from 0 to t. You put some constant DC value also you are getting here. You can see that. Okay, so if you are finding out the current, no, then better find out first voltage, then it will be easy for you to find out if you know how to integrate. Only the integration part is the important part. Okay, so just you do the integration, you will get the answer. Understandable? So better than better finding out the complete transfer function like this, I naught as y v in s, then you convert it into inverse Laplace and all. Without even applying the Laplace transform as well, we can do it. How did we do it? That first we can find out v naught t without applying the Laplace transform. This is the v naught t we are getting, and now what we can do is that we can simply integrate to get it. So simply the integration will give us it. So you can get the answer, and you can directly see here if I put the limit, some constant DC part also I am getting. This 3t by L2, this part I am getting as well. Along with that, there is some constant DC part as well. Because if you put the limit, e to the power 0 will become 1. Right? E to the power 0 will become 1. So 1 into 3 into 0.6, that means 1.5 minus 1.5. This minus 1.5, and some exponential part would also come. Plus some exponential part would come, that I don't care. So this minus 1.5 is also coming here. That minus 1.5 is important. Okay? Yeah, that's it. Okay then. Thank you. Yeah, so let's see the solution of all the aptitude questions. So I need to find out the cost price of the article. Let's just say the cost price of article was X. Okay. So what he has done, he has marked the cost price 40% above. So what will be the 40% of X? That will be 0.4x. That means he would have marked the price as X plus 0.4x. That means he has marked the price as 1.4x. Now he is first offering the discount of 10%. 10% on this price. That means what will be the 10% of 1.4? That will be 0.14. So from 1.4x he is giving us a discount of 0.14x. That means as of now the article is available in 1.26x rupees. Then again he is offering a discount of 20%. So what will be the 20% of 1.26x? The 20% of 1.26x would be 0.252, right? 0.252. So as of now it is available in 1.008x rupees. So the particular thing is available in this much rupees, but actual price is 1.008x. Actual price is equals to 1008. That means x has to be 1000. So basically the scenario was that he bought it in 1000 rupees. Then he made the price as 1400. Then first he provided a discount of 10%. What will be the 10% of 1400? That will be 140 rupees. 140 rupees means he is selling it in a 1260. Then again he provided a discount of 20%. What will be the 20% of this? That will be 20% of 1260 would be nothing but complete brain fade. That would be 252 rupees. So he is giving a discount of 252 rupees. That means now the price is 1008. This is the scenario. That means he is earning a profit of 8 rupees. But what they asked, that what was the cost price? So this was the cost price. Okay, 1000 rupees was the cost price. Next question: a train is traveling. A train travels 120 km at a certain speed, and then 180 km at a speed 20 km per hour greater. So initially he is working. Initially the train is moving with the speed of x km per hour. Then it is moving with the speed of x plus 20 km per hour. Right? So they are moving 120 km with this one and 180 km with this speed. Right? So how much time they would have taken here? The total journey is taking 6 hours. So how much time they would have taken here? Sir, kilometer per hour. Then what I would do? 120 divided by x. This much time they would have taken. No, because unit here is kilometer and here it is kilometer per hour. So kilometer get cancelled out. So they would have taken 120 by x hours. And here how much time they would have taken? Here they would have taken 180 divided by x plus 20 hours. And total journey is of 6 hours only. That's it. Now what you are supposed to find out? You are supposed to find out the value of x. So 40, x equals to 40. Without even solving, I can see x equals to 40. I could have checked with the option as well, x equals to 40 km per hour. You could have understood 120 km with x km per hour, 180 km with x plus 20 km per hour. You need to find out the time. So what will be the time? Distance upon speed. Time would be 120 by x. Distance upon speed. Time would be 180 divided by x plus 20. Both time combined equals to 6 hours. That's it. Okay. So x is coming out to be 40 because 120 divided by 40 will be 3, 40 plus 60, 40 plus 20 will be 60. So this will also be 3, 3 plus 3 will be 6. So answer is 40 km per hour. Next question. In how many ways a committee of 4 students could be framed? 4 students could be framed selected from 6 boys and 5 girls if the committee should have at least 2 girls. So that means what are the ways? 2 girls, 2 boys, 3 girls, 1 boy and 4 girls, 0 boy. This is the scenario. That means from 5 you need to choose 2 and from 6 you need to choose 2 plus from 5 you need to choose 3 and from 6 you need to choose 1 plus from 5 you need to choose 4. That's the scenario. What is the value of 5c2? So 5 into 4 divided by 2, 5c2 is nothing but 10. अरे यार क्या हो रहा है भाई, हैंग क्यों हो रहा है इतना? 5c2 is nothing but 10. What is the value of 6c2? So 6 into 5 divided by 2, so that would be nothing but 15. That would be 15. 5c3 is same as 5c2, that will be 10 only. 6c1 will be 6 only, plus 5c4 will be same as 5c1. So 150 plus 60 plus 5. What is the answer? 215 ways are there. So answer is 215. Next question. Persistent. Okay, persistent means someone who doesn't give up. Are you the same kind of person? Despite failing in this examination, I know this question paper is actually very tough only. So despite failing here, you remained persistent and got a very good rank in GATE examination. GATE examination is having 200 days. 200 days are left, no? So we have 200 days, no? Put up the level best. Okay, put up your effort for next 200 days and see the results. 200 days we have, right? We have that time. This is a wake-up call that we will perform, we will study in a good manner. So you stay persistent. And do you know the answer of this question? I am not giving you the question. You already know the answer of this question, which is this one, right? You already know the answer. Why you already know the answer? Because you have read the paragraph. So those who have written this question paper, those who have read the paragraph, they would know the answer in a good way. Okay, so this is the answer. You would have understood the meaning of this paragraph as well, and everything is clear to you. Okay, so prepare well, prepare in a good manner. The solutions are completed. So I will just talk about my courses. So as of now, we are running the promo code PREP. PREP, this is the promo code we are running. You can apply the promo code. Two kind of batches are there for GATE examination, Pathfinders and Titans. If you are someone preparing for placements, then this is the course for you. So for Pathfinders and Titans batch are there. In Titans batch, you will get the recorded video lectures, complete video lectures you will be getting. Dedicated doubt solving would be there, and personalized one-to-one mentorship would also be there. Slides you will be getting, printable notes you will be getting, solutions to assignments and important PYQs also you will be getting. You will be getting test series with this kind of challenging problems that we have seen in this particular test series. You would have seen the level, no? So this kind of questions you will be getting along with the video solution, And when I say personalized doubt solving, that means I personally will be clearing all your doubts. And one-to-one mentorship, that will be also with me bi-weekly. It will be bi-weekly mentorship. Okay. So after every 14 days, you will be connecting. So I will be talking to you, and we will be talking about your progress. Along with that, you will be getting the test series, also revision videos and short notes also you get. Along with that, you can see the access. Access is there till 30th of June. So after the GATE examination, you might have to appear for some interviews. So for those interviews as well, I will get you prepared. For VLSI kind of interviews, like for MTech MS interviews, how will you prepare? From here only you will prepare. Okay, so this is for the Titans batch. Pathfinders batch is like mainly it is having the video recorded lectures and doubt solving. Along with that, slides, printable notes, solution to important PYQs, revision videos, everything you will be getting. Here the point is that you don't get post-gate guidance. Okay, you don't get the post-gate guidance. You don't get the VLSI interview prep. Along with that, you don't get the test series as well. Also, you don't get the one-to-one mentorship as well. Here, doubt solving would be there. Video lectures would be there. Class notes are there. Printable notes are there. Revision videos are there. Test series is not available. One-to-one mentorship is not available. And post-gate guidance is also not available. So if you are someone who is preparing for the first time, then you should go with Titans batch. If you are someone who is preparing second time or third time, you already know that, sir, post-gate guidance and all, everything I can manage on my own. Test series, sir, I will buy. Okay, I just need the video lectures. I need just your content. Then you come here. Okay, along with that, I need the notes as well. I need the doubt solving as well. That, sir, if I am getting some doubt, you clear it. and along with that, sir, I need assignment and PYQs and all these things I need, then you come to Pathfinders. Okay, so that's the scenario. That's it. I hope you would get a good learning from this particular test. Thank you very much. Happy learning.